Hey guys, I hope you guys are doing well and I hope you guys are studying hard. So first and foremost, for those that don't know me, my name is Dan or Daniel and this is my YouTube channel, Maths with Dan, where I go through walkthroughs of past papers, predicted papers, as you can see from the title of this video, for GCSE and A-level. I'm also on Instagram, I'm also on TikTok, just going through random short fire questions or quick fire questions, I should say. And yeah, so you can find me on any of those platforms. Now, welcome to the paper one or the predicted paper one for A-level maths Edexcel. And super happy that this is finally out. It's taken a long time, as you can imagine, but it's out now. So what have we got here? We've got 15 questions. There are 112 marks, if I'm not mistaken. So I'm giving you 2 hours and 15 minutes. Now, if you're stumbling across this video without doing the paper, I'd highly recommend you do the paper first and come back. I'll pin the link to the paper in the comments. I'll also put in the description. And you can also find it on my website, MathsWithDan.com. Just go to the front page, you'll see predicted papers. Click on it, you'll find it there, no problem. So what else do I need to say? The timestamps will be in the description, so you can just quickly access whatever questions you need. I don't think there's anything else I need to say other than, yeah, good luck. And I'm sure you guys are going to do amazingly well regardless. So let's get into the paper. Okay, so question 1 says the arithmetic series S is given by S is equal to 7 plus 11 plus 15 plus 19 all the way up to 243. Part A says find the number of terms in this series for 2 marks. So we're dealing with an arithmetic series. They ask us for the number of terms. We can see quite clearly that this is going to be the last term. Remember, each of these terms have a position in the series or the sequence, right? What I want to figure out is what position this is, right? And if I call this the nth term, then I'll be able to do that. Now remember, there is a general formula for the nth term of a arithmetic series, or sequence. I'm going to say the nth term, we know, is equal to a plus n minus 1d. Okay, now we can see that this term is 243. So all I need to do is just plug in 243. What is the first term? Well, the first term is a, which is 7, plus the common difference. How do we go from one term to another? We are adding 4, aren't we? Right, so d is equal to 4. And then I can just set up this equation here. I'll put the 4 at the front, set up this equation here, and then work backwards to figure out what n must be. And that will be the number of terms in the series because 243 is the last term. So all I'm going to do now is I'm going to take 7 away. So if I take 7 away, that will give me 236. And that will equal 4n minus 1. And then dividing that by 4 would be 200 divided by 4 is 59. 59 is going to equal n minus 1. So therefore, adding 1 to both sides, n must equal 60. So there must be 60 terms in this series, okay? So let's try 60 terms. Perfect, that's part A. Part B, it says the sum of the series. So again, there's a formula for the sum of the series is Sn is equal to n over 2, 2a plus n minus 1d. Now, because there are 60 terms, we're just going to do S60 with everything that we know. So S60 is just going to equal 60 over 2 times by 2 lots of A, which was 7, plus n minus 1. If n is 60, n minus 1 is 59, and d is 4. So all I need to do is just put this into my calculator, just simplify it a little bit more. That is 30, that is 14, and that one I'll just leave like that. So what is that going to be? Just put this in the calculator. That is going to be, can you see that? Yeah, you can. 30 times by 14 plus 59 times by 4. And then that will give me 7,500. So the sum of the series is 7,500. And that's it for question 1. Okay, so question 2 says f of x is equal to 3x cubed plus ax squared minus 10x plus b, where a and b are constants. Given that 3x minus 4 is a factor of f of x, part A says show that 16a plus 9b is equal to 56 for 2 marks. So this is just the factor theorem. What you always want to do first is we've got the factor 3x minus 4. Set that equal to 0. That would mean that we add 4 divided by 3. So x will equal 4/3. And from the factor theorem, what we could say is that f of 4/3 must equal 0. So all I've got to do is plug in 4/3 into the function, equate it to 0, and show that we get 16a plus 9b. So doing that is going to give me 3 times 4 over 3 all cubed, plus a times by 4 over 3 all squared, minus 10 lots of 4 over 3, plus b is equal to 0. And then from here, what can I do? Well, I can, let's evaluate that. That's going to be 64 over 27 plus a times by 16 over 9 minus, that's just going to be 40 over 3 plus b is equal to 0. Now, what do they want? They want 16a plus 9b, okay? So we can see that we've got fractions now. So let's just tie this up a bit. 3 over 27 is a ninth, isn't it? So I can actually just write this as 64 over 9 plus 16a over 9. I'm just going to write like that to be fair. And then minus 40 over 3 plus b is equal to 0. And then let me times through by 9 to get rid of all of the fractions. So times and everything by 9 will give me 64 plus 16a. If I times it by 9, 9 over 3 is 3. That'll be minus 120. And then if I've got to times the b by 9 as well, so it'll be 9b is equal to 0. And then tidying this up, I have 16a plus 9b, which is what they want. And then I've got 64 minus 120, which is minus 56, isn't it? So therefore, we can say that 16a plus 9b is equal to 56 as required. That's what they wanted, right? Yeah, fantastic. Now that's done. Part B. Part B says, given also that f of 2 is equal to b, find the value of a and the value of b for 3 marks. So I've just got everything that we need to answer this question. So we've got a function f and we figured out, or we showed that 16a plus 9b was equal to 56 in part A. They asked us for the value of a and b, so it's just a simultaneous equation. And we get the other equation by using this information here. So f of 2 is equal to b. So what does that mean? Plug in 2 for x and equate it to b. So doing that will give me 3 lots of 2 all cubed plus a lots of 2 squared minus 10 lots of 2 plus b will have to equal b. And then what can I do from this? Tidy up. I've got 2 cubed, which is 8. 8 times 3 is 24. So I've got 24. And then plus 4a minus 20 plus b is equal to b. Now what happens here? I've got 4a. 24 take away 20 is a plus 4. And then these b's will cancel, won't they? If I take b away from both sides, I'll just have 4a plus 4 is equal to 0, which means that 4a is equal to minus 4. And that must mean that a is equal to negative 1. So now that I've got a, I can use that to figure out what b must be, okay? So doing that, I can plug that into this equation here. So that means I'm going to have 16 times minus 1 plus 9b is equal to 56. Minus 16 plus 9b is equal to 56. Add on 16. So I'm going to have, what would that be? 66 add 6 is 72. Yeah. And then b is equal to 72 over 9, which I know is 8. So b is equal to 8. So therefore, the values of a is equal to minus 1 and b is equal to 8. So that is part B done. Now part C, which I thought would be on this page, but I can actually just move this up now. Why not? So let me copy that. Let me cut that and then put this here. What does part say we need to do? It says, hence using algebra, fully factorize f of x. So this is just, yeah, factorizing it. So this is f. We now know what a and b are, so we can put these in, can't we? So if I put those in, what do we have? We have a equals minus 1 and b equals 8. So if I put those in, that will tell me exactly what f actually is in its full form. So f of x will equal 3x cubed, and then a is minus 1, so that'll be a minus x squared, and then minus 10x, and then b is 8. So I have to fully factorize this. Now remember, from part A, we know that 3x minus 4 is a factor. So what I can do is use long division to figure out what the quadratic factor would be and then see if that can be factorized. So I'm going to use long division with 3x minus 4. Right. It's going to be 3x cubed minus x squared minus 10x plus 8. So what are we going to get? Firstly, 3x cubed divided by 3x. I'll do it here. 3x cubed over 3x. The 3's will cancel. This is just x squared. So that will go there. And then this x squared, you're going to multiply by this factor that you're dividing by. X squared times 3x will give me 3x cubed. X squared times minus 4b minus 4x squared. Like that. And then now we take these away, take away, take away. That will go. Minus x squared minus minus will be a plus, right? So it's going to be minus 1 plus 4, which is a positive 3. So it's going to be 3x squared, and then we bring down this minus 10x. Like that, and then repeat the process. So now we're going to do 3x squared, and we're going to divide this by the 3x. And that will give us, 3's will cancel, this will be x, like that. So it'll be plus x. like that. And then we times the x by 3x minus 4, don't we? So x times 3x is going to be a 3x squared. And then x times minus 4 is a minus 4x. And then we're going to do that. And we're going to take these away. So take away. That will go minus 10 minus 4. Minus 10 plus 4 is minus 6. It'll be minus 6x there. And then we bring this down, don't we? So bring the plus 8 down and do the exact same thing. Minus 6x divided by 3x is going to be 6 over 3 is a 2. There's a minus there. And then x cancels, so minus 2. Like that. So now we are here. That's it. And no, obviously, no, that's not it. Minus 2 times by the 3x minus 4, show that you get 0. So minus 2x times by 3x is a minus 6x. And then minus 4 times by minus 2 is a plus 8. And these are the exact same things. And when I take them away, I will get 0, which means that there's no remainder. So this is divided perfectly. So therefore, what we can say now is that f of x is just going to equal the linear factor that we figured out was a factor, or that they told us is a factor in part A, multiplied by the quadratic factor that we just found, plus x minus 2, like that. Now they said fully factorized. So can this be factorized further? We can say, no, I don't think it can, you know. Let's do the discriminant. If I do the discriminant here, we're going to have b squared minus 4ac. So that would be, what would that be? 1 squared minus 1. 1 squared minus, I said 1 minus 1. 1 squared minus 4. B squared minus 4. And then a would be 1. C would be minus 2. What's that? That is 1 plus 8. So there are roots. So what are the roots then? Let me just double check. B squared is 1 minus 4 times 1. Yeah, that's fine. So what are the roots? This is factorized. Minus 2. Oh, of course. I was thinking, of course. Duh. Of course. Positive 2 and a minus 1, isn't it? Those would be the factors there. Okay. 3x minus 4 would be x like that, x like that. It would be x there, and it would be plus 2. It'd be minus 1. So this would be our final answer. I was thinking, it didn't look like it factorized. I was looking at the minus 2, and I was thinking in my head, it's a minus 1. But yeah, perfect. So that is our final answer. Have I written that in a neat way? Let me tie this up a bit. Hold on. Write this again. So final answer is going to be x, what was it again? Plus 2, x minus 1. And then I guess, yeah, that's fine. That would be the answer. And that is question 2 finished. Okay, so question 3 says the function f is defined by f of x is equal to 4x plus 3 over x minus 2, where x is never equal to 2. Part A says find the inverse of f for 3 marks. So inverse functions, very, very straightforward. All you're going to do is just literally, it's GCSE, isn't it? Set equal to y, interchange x to y, make y the subject, blah, blah, blah. So let's just do that. Let me put this over here. And then I'll just do that. So the inverse is going to be, firstly, we're going to set this equal to y. So I'm going to say that y is equal to 4x plus 3 over x minus 2. And then we're going to swap x and y over. So it's going to become x is equal to 4y plus 3 over y minus 2. And then what are we going to do? We are going to make y the subject. So I'm going to times that by y. So I'm going to have x times y minus 2 is equal to 4y plus 3. I'm going to expand the y. So it's going to be xy minus 2x is equal to 4y plus 3. And then what am I going to do? I'm going to move the y to the left, x to the right. So it becomes xy minus 4y is equal to, I'll put the 2x at the front, 2x plus 3. Take out the y. So I'm going to have y, and I'm going to have x minus 4 is equal to 2x plus 3. So therefore, we can say that y is equal to 2x plus 3 over x minus 4. Now that I've made y the subject, we just replace it with the inverse. So therefore, we can say that the inverse, f minus 1 of x, is going to equal 2x plus 3 over x minus 4. Now, currently, we are at 2 out of 3 marks. To get the final mark, what you should always remember, whenever they ask you to find the inverse function, should always state its domain. So the domain of this function here, it's a rational function. There's only going to be one value where it doesn't work. Well, there's only going to be one value of x which doesn't work, which is going to be when the denominator is 0. So all you want to do for this one is just say that, well, x minus 4 is equal to 0. that means that x will equal 4, right? X equals 4, if I put that in, will not work. So we just put a line through. X can never equal 4, and x is an element of the rules. And that will give you 3 marks out of 3, okay? You must state the domain. They haven't put reals, but it's fine. So yeah, that's literally it for part A. Part B, it says show that f of x is equal to x plus b over 6 plus d, where a, b, c, and d are integers to be found for 3 marks. So let me put that over there. So we're just putting f back into itself, isn't it, for this one? So we put this over here and then see what we get. So put that there, and then let's get f as well. F was that, so let's grab that as well. Okay, so pasting that there, and then we're just going to put f back into itself for this question. So f of x, that just literally means, do it here. So f of x, so f of x, what I like to do is put an input there. That tells me that f of x is my input. So remember, it's going to be 4 f of x plus 3 over f of x minus 2, okay? So all we're going to do is just put that into itself. So it becomes f of x is going to equal 4. You know, I'll do actually just so you can see it clearly. It's going to be 4, and then it's going to be in a bracket 4x plus 3 over x minus 2. And then plus 3 all over. And then again, it's going to be like that. It's going to be 4x plus 3 over x minus 2. Minus 2. 4 times that plus 3 over the same thing minus 2. That's fine. So now we need to show that we get this form here. So we just need to combine fractions, so on and so forth. So let's do that here. This one, if I do that, is going to be 16x plus 12 over x minus 2. I'm just expanding that 4 with the numerator here. And then I can actually write this 3. If I put that over 1, I put that over 1, to be honest. We can actually write this as 3x minus 2 over x minus 2, all divided by, and then the same thing. So 4x plus 3 over x minus 2 minus 2 over x minus 2. X minus 2 like that. I don't need a bracket on the denominator, to be fair. So like that. So this is where we're at. So let's tidy this up. We've got this same denominator now. So what I'm going to do, I'm going to just write this here. So it's going to become, put a big fraction bar, and then it's going to become 16x plus 12 plus, and then that one I can expand. It will be 3x minus 6 all over x minus 2 divided by 4x plus 3 minus, and then you got to be careful with this minus, to be honest. Should I, let me just put a minus and put it like that, just so it's super clear, because you don't want to miss that minus out, like that. X minus 2, and then we can expand. So let's just tidy this up. This is going to be 16x plus a 3x is a 19x, like that. 12 minus 6 is a plus 6. This is over x minus 2. This one now is going to be 4x plus 3 minus 2x plus 4, isn't it? Over x minus 2. And that is going to equal 19x plus 6 over x minus 2 over 2x plus 7 over x minus 2. And then from here, what do we have? We're dividing by a fraction. So this is the denominator. We're dividing by this. So I do that there. We can say that this is just going to become 19x plus 6 over x minus 2 multiplied by, and then the reciprocal x minus 2 over 2x plus 7. That cancels with that, and then therefore we can say that f of x is equal to 19x plus 6 over 2x plus 7. And that is our answer for f of x. And that is part B, and that will give you the 3 marks. Okay, so part C says a student attempts to solve f of x equals the inverse. Explain why solving f of x equals x would give the same solutions. You do not need to carry out this calculation for 1 mark. So before I start, remember when you're doing these questions, just with A-level maths in general, it's very good to learn how to compute the methods, learn the formulas, etc., understand it that way. But you also need to have a really good understanding of the topics themselves and why they work and how they work, right? So with functions, remember when you're dealing with functions and its inverse, the first thing you should remember is that they reflect in the line y equals x. So I'm going to do, which you don't need to do for the mark, but I'm going to just draw a sketch anyway just to signify what I mean. Where is my, there we go, there's my cursor. I'm going to just draw an axis. I'm going to get axes going. What I'm going to do, I'm going to just draw two random functions. I'm going to draw one as f and one as my inverse. So let's just say I do my function like this, right? Let's just say this is y equals f of x, right? And then I'm going to say that this point here is x is minus 5, and I'm going to say this point here is y equals 4, sorry. Now the inverse function, remember x's and y's swap. So if x equals minus 5 here, that means that y will have to be minus 5 for my graph here, like this. And if y was 4 here, that means x will have to be 4, and that'll be there. And then I'm just going to draw this in and make sure it's like a reflection in the line of y equals x, so something like that. And I'm going to label this line y equals f minus 1 of x. And then remember, from functions, these two reflect in the line y equals x. So what I'm going to do here is I'm going to just draw a line through it like this, and I'm going to call this line y equals x. Okay, as we can see, the graphs intersect at that point. So all you have to say for this is you just need to say, firstly, f of x and the inverse, right, reflect in the line y equals x, right? So therefore, their points of intersection, are on y equals x, right? And at this point, as you can see from the graph quite clearly, f of x equals x. So that's all you need to say. State that f and its inverse reflected on y equals x. So obviously that would mean that their points of intersections are on y equals x. And what does that mean? At this point, as you can see from the graph, f of x equals x. And what you can actually say as well, you don't need to for this one, but from here, you can actually say that, well, or you could realize that another point of intersection or another way of solving it would just be the inverse of x is equal to x. If you solve that, you get the same thing as well. That's a pretty cool way of doing it. So that's it. And that will give you the 1 mark. Okay, so question 4 says the growth of a weed on the surface of a pond is being studied. The surface area of the pond covered by the weed, a meters squared, is modeled by the equation a is equal to 80 pe to the 0.15t divided by pe to the 0.15t plus 4, where p is a positive constant and t is the number of days after the start of the study. Given that 30 meters squared of the surface of the pond was covered by the weed at the start of the study, 50 meters squared of the surface of the pond was covered by the weed t days after the start of the study, part A says show that p is equal to 2.442 mark. So firstly, from this first bullet point, 30 meters squared, remember, A is the surface area of the weed. So A equals 30 at the start. But if you see at the start, if you see initial, that just means T is equal to 0, doesn't it? So from there, T is equal to 0. And then from there, A is equal to 30. So what I'm going to do is plug these into the formula. And then hopefully I'll get P equals 2.4. So let's do that for part A. So I'll do it here. Part A, let me get the equation again and then put it up. So for part A, we are saying that a equals 30 and t equals 0, isn't it? So plugging that in, a equals 30 and t equals 0. That would give us 30 is equal to 80 p e to the, if I put that as 0, then this whole thing would be 0, wouldn't it? And then that would be p e to the 0 plus 4. What do we have here? We've got 30 is equal to e to the 0 is 1. So I'm going to have 80p at the top divided by p plus 4 on the bottom. So I need to solve that. So times up the p plus 4. I'm going to have 30p plus 120. If I times it up, it's going to equal 80p. So then from there, I can say that 120 is going to give me 50p. So therefore, I can say that 120 over 50 is going to equal p, which is, I'll do it right here. P is going to equal, that would be 12 over 5, which is equal to 2.4. So therefore, P is equal to 2.4 as required. And that is part A. Perfect. So that's part A done. Part B says find the value of capital T given your answer to one decimal place. So capital T is from the second bullet point. They said that 50 meters squared of the surface area of the pond was covered by the weed capital T days after the start. So I'm going to plug in A equals 50 and plug in T for capital T, solve it and see if I get that. And also we know what P is as well, don't we? So let me just copy that and then put all of these here. So I'll put this onto the next page. So what do I need? I need that bullet point. So I've got that there. I also need the formula for A, like that. And we also know what P is now. P is 2.4, so I can just put that in. So I think that's it in terms of part B. Yeah, I think that's it, isn't it? We've got the bullet point, we've got A, we know that P is 2.4. So with that being said, we need to figure out what T is. So what we're going to do is I'm going to set that equal to 50. Let me put part B here. Part B, set that equal to 50. I'm going to have 80. P is 2.4, so I put 2.4 e to the 0.15 t, and then 2.4 e to the 0.15 t plus 4. What is 80 times 2.4? 80 times 2.4 is 192. So I can change it to a 192 actually. So I get that there. Okay. So this is where we're at. We need to figure out what T is. And by the way, remember capital T there, so I might as well change that to a, I mean, you won't get penalized for it, but might as well. So change this to a capital T as well. So we are solving for T. Okay. So what's the best way to do this? Let's times up the denominator again. So it's going to be 50 times by 2.4 e to the 0.15 capital T plus 4. And that is going to equal 192 e to the 0.15 capital T. So what's 50 times 2.4? Times by 10 is 24. Times that by 5 would be 120. So it'd be 120 e to the 0.15 t plus 50 times 4 is 200, isn't it? It's going to equal 192 e to the 0.15 t. We're trying to find out what t is. So let's move this to the right and then move and then keep that there. So if I move that to the right, then that would be 200 is equal to 192 e to the 0.15 t. Take away 120 e to the 0.15 t. 192 take away 120 is 92 take away 20, which is 72, isn't it? So 200 is going to equal 72 e to the 0.15 t. Now we're trying to figure out what t is. T is in the power. It's an exponential equation. We need to get let's divide by 72 first. It's going to equal that. What's that? Let me just do that in the calculator. 200 over 72 is equal to 25 over 9. So therefore I can say that this is just equal to e to the 0.15 capital T is equal to 25 over 9. Now, as I said before, we're trying to find out what t is. We've got it in the power. We have to take log. So the base is e, so we're going to take the ln of both sides. So it'll be the ln of e to the 0.15 t is equal to the ln of 25 over 9. The power can drop to the front from our log law, so it becomes 0.15 t ln of e is equal to the ln of 25 over 9. The ln of e is 1, so it's just literally 0.15 t is equal to the ln of 25 over 9. So therefore t, whatever that is going to be equal to the ln of 25 over 9 divided by 0.15. So what is that equal to? T is going to be the ln of 25 over 9 divided by 0.15. That is equal to 6.81. So 6.81. What did they say for it? They said find the value of t. T days. So 50 meters of the surface pole was covered by the weed t days after the start. So to one decimal place. They said it's to one decimal place. That's fine. So that would be 6.8, isn't it? 6.8 days. So that's what they wanted. So that's part B. Okay, so part C says the weed grows until it covers the surface of the pond. Part C says find, according to the model, the maximum possible surface area of the pond for 1 mark. So this is the formula here for the area. the surface area of this pond, and we're saying the maximum possible surface area. What happens as time is going? It says the weed grows until. Until means that time is going on. Is anything gonna happen as time goes on? If you think about it, right? As t tends to infinity, if you just think of it from an algebraic standpoint, right? These two expressions here with e to the 0.15t, right? These are going to dominate, right? They are exponential terms. They're going to increase rapidly. So what we could say as t tends to infinity, you can actually think of a just becoming equal to, for large t, ATP e to the 1.5t, 0.15t over p e to the 0.15t, right? Because that 4 essentially is just going to be insignificant for large values of t. And then from here, what can we say? Well, that will cancel with that. The p's will cancel. A just left with 80. So therefore, you could say as t tends to infinity, a will tend to 80. Okay? So the maximum possible surface area we just say is 80. You can just use 80 meters squared. As well as another way you could think of it as this right here, you can actually just divide it as well. So what you could do is you could also say divide every single term by this dominant term here, e to the 0.15t. What would happen? Then let's just do it here. Divide every single term by this, like that, top and bottom. Then you'll be left with 80p on the top, and you divide this by p plus 4 over e to the 0.15t. And then what will happen here is a lot clearer. As t tends to infinity, this is now on the denominator. This will get really, really big, which means that this fraction will become very, very small. And essentially for large values of t, as t tends to infinity of that, you'll just be left with 80p over p plus 0. This would be nothing when t is really, really big, which again is just 80p over p. Cancel, you're left with 80. So any way you slice it, you're always going to get 80. And if worse comes to worse, just punch in a really big number in your calculator and you'll see that it will approach 80 as well. But the answer is definitely 80. So therefore, you just write your unit, 80 meters squared. And that's it. Okay, so question 5 says, the equation 1 over x minus x equals 0 has a positive real root. Part A says, show that for this equation, the Newton-Raphson formula can be written as xn plus 1 is equal to 2xn over 1 plus xn all squared for 3 marks. So this one is actually a very similar question to, I think it was paper 2 of June 2018. That's where I adapted it from. I thought it's a pretty cool question. So all you got to do is remember the general formula for your Newton-Raphson, which is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So all you got to do here is figure out what f is, what f dash is, put it in, use algebra to get that result. So f of x, we know is obviously the equation, which is equal to 0. So f of x is going to equal 1 over x minus x, which obviously means that f of xn, if I just put n's there, it's going to be like that. So let me put n's there, put an n there. That will just be an n there, and that will be an n there. Now, f dash of xn, we need to differentiate this. So how would we get that? Well, firstly, let's rewrite f of x on top, and then write this as 1 over x to the minus 1. So it'll be x to the negative 1, isn't it? And then minus x, right? This is just f of x in index form. F dash of x, we bring the minus 1 to the front. So minus x to the minus 2, and that'll be minus 1. So therefore, we can actually just write this as minus 1 over x squared minus 1. This is f dash of x. So if I write f dash of xn now, like that, then I could put an n there, and then that would be it. So now I can apply the Newton-Raphson. Remember, I need to get that result there. So what I'm going to do, let me compute it, plug everything in, and then I'll bring it back. So xn plus 1 is going to equal xn minus f of xn, which is this expression right here, which is going to be 1 over xn minus xn all over 1, oh, there's a minus there, minus 1 over xn squared minus 1. This is where we're at. So what we need to do is obviously, but look at this, we've got that expression there. So this is just one fraction on the right hand side. So we need to just get that. So we need to just simplify that fraction, combine it with the xn term, and then we should hopefully get that result. So let's see if we get that. So first thing I'm going to do is I'm going to start with the fraction, the numerator. So xn minus, and then on the numerator, I'll do it here, is going to be 1 over xn minus, and then it will be xn squared over xn, wouldn't it, right? If I get the same denominator, yeah, that would be fine. And then on the denominator, it would be, I need the same denominator. So it'd be minus 1 over xn squared minus, it would just be xn squared over xn squared, wouldn't it? Like that. So this is where we are at, and we need to get this result here. So what can I do from here? Let's combine. So it's going to become now, I'll do it here, xn minus, and then the numerator will just simply be 1 minus xn all squared over xn. Same denominator. And then on the denominator, it will just be, you know what I'll do? They're both negative, actually. Yeah, I'll do this. It'll be minus 1 minus xn all squared, like that. And then that will be over xn squared, like that. And then from here, what I can do on the denominator, I'll just put this in brackets so it's clear to see. Just do that again, 1 sec. So just be like that, and then like that, and then like that, and then like that. Let's tally this up. So I'll do it here. So that would be xn. Remember, this is xn plus 1, by the way. Xn plus 1 is going to equal xn minus, and then I will do this. I will keep that. I'll keep that. So it becomes 1 minus xn all squared over xn. And then it will be, I could take out a minus from there. So if I take out a minus, it will be minus 1 on the outside, and it'll be 1 plus xn all squared on there, and then over xn squared. Like that. And then from there, what can I do? I can flip this, can't I? So what I can do actually is that these two minuses, this is a minus 1 there, and that minus 1, that can actually cancel, can't it? So what I'll do, just to make it super clear, it's going to be xn minus, and then it would be 1 minus xn all squared over xn. And then we're dividing by this, so we can times by it. So it'd be times, and then it would be xn on the top, xn squared on the top, over minus 1 plus xn all squared on the bottom. Like that. Okay, and then now from here, I think it's clearer a bit. That minus and that minus, we can just cancel out. All right, so they're both minus 1s, so we can just cancel them, so it becomes a plus. So therefore we can now say that we're going to have xn plus 1 is equal to xn plus those two, which is going to literally be, if we times this together, it will be xn all squared times 1 minus xn, like that, over xn, and then 1 plus xn all squared. So this is where we're at right now. So what I'm going to do, where do we have to show that? We have to show that right there. So we need 2xn on the top. So let me copy this and put this on the next page, and then hopefully we can get that. So copy this here, put this on the next page, and then put the show that as well, because I think we're nearly done. Okay, so this is where we're at. And then we need to get this expression here. So always have a look at what you're trying to show with these questions. So I've got this here. Okay, so looking at where we're at and where we need to get to, I think we're in a good position, because what I can do now is I can say that with this one, I can cancel out this xn, and then I can take 1 away from there. So that way I'm going to have, this will just be equal to xn plus, and it will be xn times 1 minus xn squared, like that, over 1 plus xn squared, like that. And then tidying this up, what are we going to have? Well, what we can do is we can get this to be the same denominator now. So it becomes xn 1 plus xn all squared, like that, over xn. So not over xn, 1 plus xn squared, like that. This is this term right here, and then we're going to add on this one, like that, over 1 plus xn all squared. So now we've got the same denominator. We can combine these. So it's going to become, let's do it like this. We're nearly done. I can see what's going to cancel now. Xn, 1 plus xn all squared, plus xn, 1 minus xn all squared, like that. And this is going to be 1 plus xn squared. And remember, this is xn plus 1, isn't it? So now let's expand this numerator. We're going to have xn plus xn cubed plus xn minus xn cubed all over 1 plus xn all squared. And then from there, what do we have? Well, we've got a goodbye and a goodbye. We've got xn plus xn is 2xn, all divided by 1 plus xn all squared as required. Is that what they got? Whoosh. Fantastic. So that's it. And that is that's part A. Okay, so part B says, using the formula given in part A with x1 equal to 2, find the values of x2 and x3. So it's just standard iteration. So I'm going to just get my calculator and put that in. So x1 is equal to 2. So that's our starting value. So I'll click equals to store it and put the formula in. So it'll be 2 times answer over 1 plus answer squared. Click equals once. That will give me x2. So x2 equals 4 over 5. So let me write that there. So at part B, x2 is equal to 4 over 5. And then x3 will just equal equals again 40 over 41. Okay, so you just put those down. So these are our two answers, 40 over 41. So that's part A. Part B. Part C says, explain why for this question the Newton-Raphson method cannot be used with x1 equal to 0. So although it may look valid when you actually do the algebra and get this expression here, just remember the definition of Newton-Raphson. Remember, let me write here. It's xn plus 1 is equal to xn minus f of xn over f dash of xn. So essentially, what you need to remind yourself or be wary of is that it has to be defined for these values here. Now, if x1 was equal to 0, I've actually put f of xn and f dash of xn there. What would that be? Well, that would be f of 0 is equal to 1 over 0 minus 0. And then f dash of xn would be f dash of 0 is equal to minus 1 over 0 minus 1. In both cases, we are dividing by 0, right? So that's why it fails. So we are dividing by 0. By 0, right? So what you could say just for the mark is both f of 0 and f dash of 0 lead to division by 0, which is not possible, obviously. Possible, so it fails. And that's it. That will give you the 1 mark. And that is question 5 finished. Okay, so question 6 says, given that the binomial expansion in ascending powers of x of 6 times 4 plus ax to the minus half is b minus a quarter x plus cx squared plus blah, blah, blah. Part A says, find the values of the constants a, b, and c for 5 marks. So we're doing binomial expansion with a fractional power. So let's get the formula first, which is 1 plus ax to the power of n. And then this is equal to 1 plus nax plus n minus 1 over 2 factorial and then ax squared. And as I can see from this one, we went up to the x squared term, so I'll just leave it there. Now, how do I get the constants a, b, and c? So I think the best thing to do here is to just literally use the formula, right? With these values here, we'll get it in terms of the constants a, b, and c, blah, blah, blah. And then just equate coefficients, essentially. So doing that, let's write this out. So firstly, I've got 6 multiplied by 4 plus ax to the minus a half. Now remember, if you look at the formula, there's a 1 here. So if you don't have a 1 here, you need to get that. You do that by factoring it out. So I'm going to do 6 times by, if I factor out a 4, it'll become 4 and then open bracket 1 plus a over 4, just divide it by 4, don't you? X, and this is all going to be to the negative a half. So from here, what we can do is say, well, fine. From our index laws, we can actually just split these two. So that 4 and then this 1 plus a over 4x to the 1 plus a over 4x, we can just split like this. So it becomes, I'll do it here, 6 times by 4 to the negative a half, and then multiplied by 1 plus a over 4x to the negative a half. And then from this, 6 times 4 to the negative a half, that is just 6 divided by, that's 6 times a half, isn't it? Which is 3. So this is just 3 right here. So actually it's just 3 multiplied by 1 plus a over 4 x to the negative a half. So what that tells me is that I'm going to use the binomial formula with this expression here, and obviously expand it with the 3 and then equate it to that to give us the constants a, b, and c. So doing that, let's use the formula now. It's going to be 3 multiplied by, what I like to do is this. Remember this is our formula here. What is n? N is quite clearly minus a half. And then we can see that a, in this case, is just going to be a divided by 4, isn't it? So now putting everything into there, it will just be 1 plus n, which is minus a half, times by a, which in this case is capital A over 4, and then x, isn't it? So you can just write it as ax like that, and then that's fine, and then plus n minus 1. So n is minus a half, n minus 1 would be minus 3 over 2 over 2 factorial, and then this would be a over 4 x all squared, like that. And that's what we want. We want up to the squared term. So what I'm going to do is I'm going to expand this, simplify this, and then I'm going to equate it to this b minus a quarter x plus cx squared. All right. So doing that, let's tidy this up first. I'm going to have 3 bracket. That is going to be 1 minus a half times a over 4. That would be minus a over 8 x. And then this one here, what I like to do with this one is just put this into a calculator, to be honest. So put this into my calculator. Let's see what I get. I'm going to have minus, so I'm going to just do the coefficient. So minus a half minus 3 over 2 over 2 factorial is going to be, where's factorial in this calculator? Right here. That will give me 3 over 8. So therefore this becomes plus 3 over 8. And then I'm multiplying by expanding that a over 4, or a over 4x all squared would be a squared over 16 x squared, like that. And then now what I'm going to do, let me just tidy these up. So 3, let me do this. It's going to be 3 bracket 1 minus a over 8 x, and then plus, and then what will this be? So let's just work this out and then we'll expand to 3. 3 over 8 times by, that is a division of 16. I'll just put 1 over 16. That will give me 3 over 128. So this becomes 3 over 128. And then I've got the a squared at the top. So I can put the a squared there and I put x squared there. And then now I'm finally in a position to expand. So therefore it becomes 3 minus, and then it will be 3a over 8x plus 9a squared over 128 x squared, like that. And now I'm finally in a position to equate it to this here, and in that way we could easily figure out what a, b, and c must be. So let me put this here and then let's equate those and then see what we get. So with this one, if I equate those, then we can see quite clearly that this constant term must be that. So immediately we can say that b is equal to 3. So I can say from there b must equal 3. And then for the next term, we've got minus 3a over 8 is equal to minus a quarter. So I'm just equating the coefficients here. So I can say from there that, I'll do it here, minus 3a over 8 is equal to minus 1 over 4. That tells me that a is just going to equal minus 1 quarter times by 8 over 3. And then there's a minus there as well. So what is that going to be? That's going to just be equal to positive 8 divided by 4 is 2. This is 2/3. A is equal to 2/3. And then now C, we're just going to equate these two. So 9a squared is equal to 9a squared over 108 is equal to C. So doing that is going to be, I'll do it here, 9a squared over 128 is going to equal to C. We know what A is. A is 2/3. So it's going to be 9 times 2 over 3 all squared over 128. That is going to be what C is equal to. So putting that in to the calculator, we're going to get 9 times by a fraction. 9 times by 2 over 3 all squared over 128. That is equal to 1 over 32. So C is equal to 1 over 32. So therefore we can say that A is equal to 2/3, B is equal to 3, and C is equal to 1 over 32. And that is part A. That will give you the 5 marks. Okay, so part B says state the range of values of x for which the expansion is valid for 1 mark. So how do we go about this? So I've just got everything that we need. Remember, just from range of validity, if I've got an expansion 1 plus ax all to the n, then this is always valid for when the modulus of this expression is less than 1. Okay, so from there, what does this actually mean? Well, this means that if I do this, we can actually split this to become modulus of a, modulus of x, and this is less than 1. The modulus of a we can divide by that, so it becomes the modulus of x is less than 1 over the modulus of a, right? That is the general rule. With our one, remember, we realized from the algebra that we were just using the binomial expansion in this here. So we have to say, for our question, the modulus of a over 4x must be less than 1. And then from here, what that means is that the modulus of x must be less than 1 over the modulus of a over 4. Now, we know what a is. A is 2 over 3, don't we? So we can say that this is just equal to the modulus of x is less than 1 over the modulus of 2 over 3, which is a, all divided by 4. And then what is that equal to? That would just be 2 over 12, which is a sixth. So from there, this is equal to the modulus of x is less than 1 over the modulus of a sixth, like that. And then from here, well, what is that? Well, that is just the modulus of 1 over 6. 1 over 1 over 6 is 6. So therefore, the modulus of x is less than 6, which is the same as saying that x is between minus 6 and positive 6. And that's it for part B. Okay, so part C says for the expansion, find the coefficient of the term in x cubed. So I've just got the general expansion for the actual formula here. So all I want to do to get the x cubed term is just continue this. I can see that for the x cubed term, the coefficient would be, remember, we have to expand by that 3. So it's going to be 3 multiplied by, and then I'll just continue this. It'll be minus a half, minus 3 over 2, and then it would be minus 5 over 2, isn't it? Like that, all over 3 factorial this time, multiplied by a over 4x all cubed, right? And then I need to get the coefficient from there. So what I can do just to make this a little bit neater is I'm going to do 3, I'm going to times this by, I'm going to work out what this is. I'm going to put this into the calculator and then see what I get. So doing that is going to be minus 1 over 2. You know, I write this as 0.5, so it's going to be easier to write. Minus 0.5 times minus 1.5 times by minus 2.5. Now that's just easier, faster to type. Let me just make sure that's all good. That looks all good to me. And then close bracket and then divide it by 3 factorial, which is 3 times 2 times 1. But I just like to write that factorial just to be on the safe side. So like that. And then that gives me minus 5 over 16. So therefore it becomes 3 times minus 5 over 16 multiplied by, and then a over 4 all cubed. A over 4 all cubed is going to be a squared over 4. Sorry, that's not a squared, sorry, a cubed. A cubed over 4 cubed, which is 64. And then x cubed. So the coefficient is going to literally be whatever this is equal to. So 3 times this times that. And remember, we know what a is. A is equal to 2/3. So all I'm going to do is put that into my calculator, and that will be the answer. So putting that in, I've got that number stored, so I could just write 3 times answer, that's the minus 5 over 16, times by a cubed. A is 2 over 3, so all cubed, divided by 64. And that gives me minus 5 over 1,152. So therefore, I could say this is just minus 5 over 1,001. What was it again? Minus 5 over 1,152. Yeah, so I could just say from here, therefore C is equal to minus 5 over 1152 x cubed. No, sorry, just the constant, isn't it? Because they just want the coefficient. So that is your final answer, minus 5 over 1152. Perfect. And yeah, that's it. All right, so question 7 says, a student states if x and y are irrational numbers and x not equal to y, then xy is also irrational. Show by counter example that this statement is not always true for 1 mark. Okay, so when you're doing these types of questions, there's only 1 mark, as you can see. There's not much you need to do. It's not like a typical proof question where you have to prove it, right? Whether that's by contradiction or by exhaustion or whatever the means you're using to prove something. The onus is on you to prove it, right? In this case, it is not. All you need to do is show for one example and one example only that the statement that they've given you fails, right? So how can we do that? We've got irrational numbers and x and y can't be the same. And we need to show that the product, right, is rational because they're saying the statement is not always true. So how can we go about doing that? Well, firstly, when I think of irrational numbers, I think of roots, right? For example, I could say let x equal root 2, like that. And then let's say, for example, y equals root 8. Now, why have I chosen these ones? It's a bit of a trick, right? You're going to make use of the surd laws that cancel. So what would this be? Well, remember, let me just write this here. These are irrational. We write irrational here. And then we write irrational here. These are both irrational numbers. Now, what happens when I times them together? I'm going to get xy, which will equal root 2 times root 8. And then from us, I wrote 18. From our surd laws, we know that this is going to become root 2 times 8. It comes under one roof, and that's root 16. And the square root of 16 we all know is 4. Now 4 is quite clearly a rational number. So got this here. So what have we shown there? We've shown that when we times two irrational numbers together, we get a rational number out. So what you can say is that irrational times irrational is equal to rational. And that clearly shows the statement is not always true. So you could just say, therefore, statement is not always true. And that's it. That's all you need to do for part A. What you could have also done as well is you could have also made use of cancelling as well, like fractions. So for example, you could have said, for example, x is equal to root 2. And you could also say that y is equal to 1 over root 2, right? 1 over root 2, if I was to rationalize that, that's just root 2 there. That's root 2 over 2, right? Which is still a irrational number. It's just half of root 2. So what we could say here is, let me just put this in the box. Let me just write this again. 1 over root 2. Right now, like this is just easier to see. xy is going to equal root 2 times 1 over root 2. The root 2's cancel, and then this is equal to 1, which is a rational number. So you could have done it like that as well. You could have just said e, for example, and 1 over e again. This is a irrational number. 1 over e is also irrational. Those cancel, you get 1 as well. So you could have used any example like that. And that is part I. Okay, so double I says, prove using algebra that for all odd integers n cubed minus n is a multiple of 8 for 4 marks. So what does it mean when you have a multiple of 8? Let's just work that out first. So a multiple of 8 is any algebraic expression, right, which can be written as 8 times something. So if you can factor out an 8 and then have a bracket with integers in it, then it has to be a multiple of 8, okay? So the first thing that I want to realize or do in this question is think to myself, is that a possibility? Can I rewrite this expression algebraically to get it with an 8 at the front and then an expression on the outside? So how do we go about doing that? Well, firstly, we are dealing with odd integers n. So let's define our integer n. We can call this 2k plus 1, where obviously k is an element of the integers, okay? So now with that being said, let's plug that into n cubed minus n. N cubed minus n will be equal to 2k plus 1, 2k plus 1, all cubed, minus 2k plus 1 within it. So let's expand that and see what we get. So this one, I'm going to write it as 2k plus 1, and then multiplied by 2k plus 1 all squared, minus, and then that would be a minus 2k minus 1. And then from here, let me expand that, 2k plus 1. This will expand to, that would just be 4k squared. 2k times 1 is a 2k, double it, 4k, and then plus 1. So I've just expanded that using the a squared plus 2ab plus b squared formula. You can obviously just do it double brackets as well, that's fine. Minus 2k minus 1. And then from here, let's expand this. So this one, with all of those terms, is going to be an 8k cubed plus an 8k squared plus, so we got that, that's fine, that'll be a 2k. And then expanding the plus 1 out of each of these is just going to be 4k squared plus 4k plus 1 minus 2k minus 1. So let's tidy this up and see what we get. So we're going to have 8k cubed plus, how many k squared we got? We got 8k squared plus a 4k squared over there. So we're going to have 12k squared. All right, plus 12k squared plus, what do we have for the k's? We've got a 2k plus a 4k, which is a 6k. Take away 2k. So these cancel. The 2k's cancel, and I'm left with a positive 4k. Like that. And then I've got a plus 1 and a minus 1. These cancel. So this is where I'm at. So I've got 8k cubed plus 12k squared plus 4k. And I need to show this is a multiple of 8. Well, what I can do is I can definitely take out a 4k, can't I? If I take out a 4k, then I'm going to have a 2k squared, like that, plus a 3k plus 1, like that. Now I'm trying to show this is a multiple of 8, so I need an 8, right? So I've factored it. Can the inside be factored? Let's try, right? Well, we've got 2k squared plus 3k plus 1. What I'm going to do it here, 2k squared plus 3k plus 1. You could use the AC method. 2 times 1 is a 2. 2 times 1 is equal to 2. 2 factors of 2, which will add to make 3. That's just 2 and 1. So therefore, I can say this is equal to bracket here, bracket here, bracket here. I put a 2k there, put a 2k there. And then you just put these two numbers in, plus 2, plus 1. And then you look to see if any of these can be factored anymore. This one I can take out a 2. And it becomes k plus 1. And then it becomes 2k plus 1, like that. And then anything I've taken out, I just cross it out. And then the actual factorization is just k plus 1, 2k plus 1. And you can just check it yourself. Just a quicker way of factorizing. So that way I can now rewrite this as 4k. And then I could write this as k plus 1. And then I could write this as 2k plus 1. Okay? So what do we have here? Well, if I inspect this closely, remember, I'm trying to get a multiple of 8, right? If I inspect these factors, then I can see that I've got a k and I've got a k plus 1. Why is this helpful? Well, k and k plus 1, these are consecutive integers, aren't they? Let's write that there. This right here, these are consecutive integers. I can't spell. Consecutive integers, right? Between any consecutive integers, one of them is even, one of them is odd, right? So I'm gonna just write, let me write here, k plus 1 are consecutive integers, right? So therefore we can say that, right, are consecutive integers. So therefore we can say that the product of k plus 1 must be even, right? For sure, because if k is an integer and k plus 1 is an integer, either k is even, and that means k plus 1 is odd, or if k is odd, k plus 1 is even. So the product itself is always going to be even times odd or odd times even, so therefore it's going to be even, right? Let me just write this here. It's either going to be even times odd or odd times even. Either way, they're both equal to even. So what I have here is that k plus 1 is an even number. So what I could do is let's just say k plus 1. Let's call it 2m for some integer m. For some m, right? In the integers, right? That's perfectly valid and reasonable. So that means that we're going to have this expression here. This expression here is going to be 4 times k plus 1, which we've said is 2m, times by 2k plus 1. And what do we have here? Well, we've got 8m, and then we've got 2k plus 1. And well, what do we have here? M is some integer. 2k plus 1 is the odd number that we started with. We've got 8 times an integer times another integer. This is a multiple of 8. So what I can say here is that we've got 8 times an integer, right? We've got 8 times an integer times another integer, which is just 8 times an integer, right? Which is equal to a multiple of 8, for sure. Right? So that now we are at 3 marks. We've used the algebra, shown us a multiple of 8. Now to get the final mark, you just have to conclude. Never ever forget to conclude, guys. You always want to get the full marks. So therefore, whatever you do now, all you're gonna do now is just literally write the statement that should prove. So what did they ask us to prove? Using algebra for all integers, for all odd integers n. Yeah, that's fine. So therefore, for all odd integers n, it's n, right? N cubed minus n is a multiple of 8. And that is it. That will give you the 4 marks. And that is question 7 done. Fantastic. Right, so another way you could have done this question is forget even about introducing 2k plus 1. You could have just gone straight into the factorization of this. So for example, we've got n cubed minus n. I can take out an n, and then I have n squared minus 1. And then what I recognize immediately is that we've got a difference of 2 squares. So it becomes n and then n plus 1 and then n minus 1. Now what do I have here? I've got an n minus 1, I've got an n, and I've got an n plus 1. Let me write those in order of size. N minus 1, n, and n plus 1, right? These are 3 consecutive integers. Now what we know is that n is odd. So if we've got an odd number in the middle, that means either side is going to be even. And furthermore, we have 2 consecutive even integers, right? So what I'm going to write is I'm going to write n minus 1 and n plus 1 are 2 consecutive even integers for sure, right? Now, why is that important? Well, when you're dealing with consecutive even integers, one of them is definitely, well, both of them are going to be multiples of 2, but the other one is going to be a multiple of 4, right? And you don't need to do too much proof for this, but you can just do a couple of examples. So for example, let's say I've got 2, 4. This is a multiple of 4. Let's say I've got 8, 10. This is a multiple of 4. So the 8 is a multiple of 4. Let's say I've got 16 and 18. Then the 16 is a multiple of 4. Let's say I've got 24 and 26. Then this is a multiple of 4. So with that being said, when you've got n minus 1 and n plus 1, you know that obviously this is a multiple of 2. Like that. This is a multiple of 4. Like that. What does that give you altogether? This gives you a multiple of 8. Right? So what you can say from here is that with n minus 1 and n plus 2, I said n plus 2, n minus 1 and n plus 1, you've got one that's a multiple of 2, and then you've got another one that's a multiple of 4. Overall becomes a multiple of 8, right? So therefore you could say n minus 1, right? Therefore n minus 1 and n plus 1, right? When you multiply them, it's going to equal, well, one of them, as we've seen, is going to be a multiple of 2, times another one, which is a multiple of 4. Multiple of 4, which overall is going to make a multiple of 8. Right? So we can just write this as, for example, 8, and then you can just say, for example, n. Right? So therefore, we can now say that n cubed minus n is just equal to, let's write it again, it's going to be n and then n minus 1, n plus 1, which is equal to n times 8m, right? Because we've proved that n minus 1 and n plus 1 is a multiple of 8, which is just 8mn. So therefore, now you just write your statement, right? For all odd integers, n cubed minus n is a multiple of 8. So yeah, let me know what you think about this way and what way you guys did in the comments, which way you guys prefer. And yeah, that's the question 7 finished. So question 8 says, figure 1 shows a sketch of a design for a badge. The design consists of a triangle OAB joined to a sector OBC of a circle with center O. In the design, OB is 3.4 centimeters, AB is 1.9 centimeters, angle AOB is equal to pi over 6 radians, angle OAB is greater than pi over 2 radians. Making your method clear, find the size of angle OAB, giving your answer in radians to 4 significant figures for 3 marks. So I've just got everything we need summarized here. So I've got the diagram and the bits and pieces of information about the actual diagram, right? And what do we know? They were trying to find the size of angle OAB, and they've told us explicitly that angle OAB is greater than pi over 2. So this angle is more than 90 degrees essentially, right? Which means that we're going to be doing the ambiguous case, isn't it? So what you want to do is obviously just have a look at this diagram. We've got this diagram right here. Let's call this angle theta. And then from there, what I can say that I've got this angle and I've got this opposite side. And then I've got this angle in that opposite side, right? So crisscross, we can use the sine rule. So remember, we're going to say that sine theta over 3.4 is going to equal sine pi over 6 divided by 1.9. And obviously, just make sure your calculator is in radians. So from there, we can say that sine theta is going to equal all of that, sine pi over 6 divided by 1.9 times by 3.4. And then that means we can get what theta is. So let's figure out what that is. Let me just write up with the sine inverse of all of that to be fair. So sine inverse of all of that is going to be sine pi over 6 divided by 1.9 times by 3.4. So let's see what that gives us in our calculator. So sine inverse of, make sure calculator's in radians, sine pi over 6, close bracket, over 1.9 times by 3.4, close bracket. That gives us 1.107, blah, blah, blah. Now remember, they've told us that our angle, the one that we need, is greater than pi over 2. Pi over 2 is approximately 1.57, isn't it, right? Because pi is 3.14, half of that, approximately 1.57. So with that being said, this is smaller than pi over 2, right? This is the acute angle. We want the obtuse angle. So how do we get the obtuse angle? Again, it's just the ambiguous case. So let me put this down here. It's going to be, let's just write angle AOB. Sorry, not AOB, angle OAB, the one that we want, is going to equal 180. Remember how sine repeats, right? Let me just write this out actually. Sine theta is equal to the sine of 180 minus, pi minus theta, like that. These are the same thing. So we want this angle here. The calculator gives us this one. So we're going to just do pi minus that angle there. And what does that give us? It's going to be the angle. So I'm going to just do pi minus that. Gives us 2.0337, blah, blah, blah. That's going to be 2.034 to 4 significant figures. 2.034 radians to 4 SF. So that is the answer. So always be aware of these types of questions whereby they can try and trick you with the ambiguous case and so on and so forth. So, okay, so that's done. Part B says find the area of triangle OAB, giving your answer to 3 significant figures. So we want the area of that same triangle. So let me draw that triangle out again. And now I have a bit more information about this triangle, don't I? So, hold on a sec. Let me just draw it a bit neater again. Like that. I think that's fine. This angle we know is pi over 6. This angle is what we figured out. So it's going to be, I think we can just use 2.034 to be honest. And then this angle we don't know. What do we know? That this is 3.4 and this is 1.9. Now, what do we want? We want the area of this triangle. So immediately we're dealing with trigonometry. Area is equal to 1/2 AB sine C, where you've got a triangle like this. This angle here is C, this is A and B. So essentially you need 2 sides and an angle in between, which for me means that I just want to calculate what this angle in yellow is because I've got the 3.4 and the 1.9. How do I calculate the angle? Easy stuff. It's just literally the missing angle in the triangle. So just do 180 minus 2 angles, but obviously we're in radians to do pi. So if I call this angle Y, I can say that the angle Y will be equal to 180 or pi. Take away these two, pi over 6 minus 2.034. And you know what? I think I've got that number stored, don't I? So just to be on the safe side, I've got it stored. I'm going to use that one instead. I'm going to just write 3. And I would recommend that, to be honest. That's just my personal preference. Yeah, and then just take that away. So it's going to be pi minus pi over 6 minus answer that will give us the missing angle over there. So therefore, it's going to be y is equal to 0.584 blah, blah, blah. So therefore, the area is literally just going to be equal to 1/2 times these two sides, 3.4, 1.9, times the sine of that angle, which is going to be that number there. Again, just always use the full value. I'm always scared when I was doing exams, so I always just do that. So therefore, it's going to be 1/2 times by 3.4 times by 1.9 times by the sine of that angle there, which I can just press answer because I've got it stored and I get that there. So that's going to be, to three significant figures, that's just going to be 1.78. So 1.78 centimeter squared to 3 SF. So that is part B. Part C, I've got down here. Okay. Part C. So it says, given that the ratio of the area of sector OBC to the area of the triangle OAB is 3 to 2. Part C says, show that the angle BOC is 0.462 radians to 3 significant figures. So what angle BOC? BOC. Okay, so this angle here, like that, let's call that X. Okay. So how do I work out that angle or show that angle is 0.462? Well, they've given us information about the ratios of the sectors of the areas. So I'm going to say that OBC area to OAB area is 3 to 2, right? So this is 2, this is 3, but we know the area of OAB. That's what we just found, is it not? It's 1.78. So because I've got that, I think I can use that. So let's just see. It's a show that question. So let's see. I'm going to use this 1.78. Now, from there, we can calculate what this area must be, right? And then obviously work backwards to figure out what the angle is. So with that being said, you're dealing with ratios. Ratios are splitting an entire quantity into parts. This tells me that 2 parts, right, is equal to 1.78, right? In terms of the area, centimeter squared. Okay, that's what this right-hand side tells me of this ratio. Whenever you deal with ratios, even from GCSE, what would one part be? Right? And then obviously once you find out what one part is, you can figure out however many parts you'd like, which is 3 parts in our case. So technically speaking, if I was to go from 1 part, if I was to go from 2 to 1 part, I would divide by 2, and then I would times by 3. So to get the area of sector OBC, we just need to divide by 2 times by 3, which is the same as times by 3/2. So therefore, this area here is going to be 1.78 times by 3 divided by 2. Again, how? The division of 2 comes from the dividing of 2 here to get 1 part, and we times by 3. So it's going to be whatever this is equal to. So let's see what we get. I'm going to use 1.78, and I'm going to see if I get what they want. So 3 over 2 is going to be 2.67. So it's going to be 2.67 centimeters squared. That is going to be the area of OBC to 3 significant figures. So I'm going to say area of can't write, can't spell, can't write, can't do anything but maths. Area of OBC, right, is 2.67 centimeters squared. They said show that the angle BOC is that. So that's fine now, because we're saying, let me draw this out again. Got a line like that, got a line like that. We're saying that this is a sector. This is the angle X that we're looking for. We're saying that this area is equal to 2.67. And we know that the radius is 3.4. So all we're going to do is just a formula for the area of a sector, which is a 1/2 r squared theta. So what we're saying essentially is that a 1/2 r squared theta must equal 2.67. So now we're just going to put everything in and then solve for X. So I'm going to say it's going to be 1/2 and then 3.4 all squared times by X is going to equal 2.67. So therefore, we times by 2, divide by 3.4 squared. So that means that X is going to equal 2.67 times by 2 to get rid of the half, and then divide by 3.4 squared, no? That will give us the answer for X, or the angle BOC. So that would be, let's put this into the calculator and see what we get. So 2.67 times by 2 over 3.4 all squared. 2.67 times by 2 over 3.4 squared, which is equal to 0.4 619, what was that? 46193, blah, blah, blah. What did they say? 0.462 to 3 figures, which it is. Fantastic. To 3SF. So that's great. And that actually means we could use that value of 1.78 and then use it moving forward. Cool. Perfect. That is part C done. Okay, so part D, it says, hence find the perimeter of the badge in centimeters to the nearest integer for 5 marks. So I've just got the diagram here. So the badge, the perimeter of the badge is obviously going to be the distance on the outside. So what I'm going to do, I'm going to highlight all of the distances. So this one, O to A, I need, that's one side. And then I need this side, which obviously is actually given to us. This side is 1.9. So I need that. I've got that, but I'm going to highlight anyway. This side in green is the arc length of that sector. And then I need this side right here. Like that. All right. So if I can figure out what these colors are, add them up. That's the answer, no? So what do I know? I know that this side in blue is the same length as OB because the center, this is the sector OBC. This center is at O. O to C is the radius. So this has to be 3.4. So I know that much. This in green is the arc length of that angle, which I do know, by the way. What was that angle again? That angle was 0.462. No. Yeah, it was. All right, so I'm going to use all of the rounded values, yeah? The ones that they've given us anyway. 0.462, that is the angle right there. This is r theta, right? So it's just 3.4 times that, which is fine. And then, what else? It's the orange one. This angle I know, right? Because we did it in one of the other questions. This is angle OBA, which I'm sure we did somewhere above. Yeah, this angle right here, isn't it? This angle Y, which is 0.584 approximately. Let me just make sure I've got that. Let me get my let me go to my calculations. 0.584 was that angle right there. So yeah, that's fine. I'll round that to 3 significant figures. 0.584, that should be fine. And then let's see, 0.584. So put that in there. So let me put it 0.584. That's the angle over there. So we need to calculate each of these. So I think what we've got to do first, let's calculate this length CB, right? CB or BC, doesn't matter. CB is going to equal r theta. The radius is 3.4. The angle is 0.462, which is what we found out in part C. So let's see what we get for that. So 3.4 times 0.462. This gives us 1.5708. Okay, so that's the length of CB, 1.5708. And then now we need to figure out what the length O to A is. Now we've got a triangle here. Let's draw that triangle out again. Triangles like that. Nah, that looks like a right angle, to be fair. Even though it doesn't matter, I'm just being extra, but let me do it again. So let's just do it like that, just so it don't look like a right angle. That's not even, sorry guys. Let me try one more time. Let me just try one more time. So slightly slanted, and then boom. Calm. So this is pi over 6. This angle right here is 0.584, the one I just found from part B, I think it was. And this is 3.4. This is 1.9. And I want this side here, O to A. Well, I've got two sides and angle between. Whenever you're dealing with this, even to my GCSE students, you've got side, angle, you've got side. If I want that opposite side, it's the cosine rule, okay? So with these questions, especially with radians, etc., they love to intertwine it with trigonometry as well. So even if you've done a bit of trig, you may not be finished. So to calculate that side, O to A, let's call it, what should I call it? Let's just call it B. No, let's just call it A. Why not call it A? Call it A, then it's going to be A squared is equal to B squared plus C squared minus 2BC cosine of A, right? So B and C are always those two sides, either side of the angle. So this one and that one. And then obviously the angle A is that 0.584. So it's going to be A squared is equal to B squared plus C squared. So those two sides, 3.4 squared plus 1.9 squared minus those same two sides, 3.4, 1.9. And then the cosine of that angle, which is 0.584. So putting that in and then square rooting, what do we get? So do it here. Let me just zoom out a bit so you can see the working out too. So 3.4 squared plus 1.9 squared minus 2 lots of 3.4, 1.9, and then cosine of 0.584. Like that. Let me just double check that's all good. That looks all good to me. Looks all good to me. Yeah, that's fine. I get that there. So a squared is going to equal 4. What was it? 3913, blah, blah, blah. So therefore, a, which is the side, is going to be equal to root answer, 2.0955. So therefore, this is 2.0955, like that. So now we are in a position to answer the question. They asked us for the perimeter of the badge to the nearest integer. So let's just add all of these together. We're going to say, therefore, P, the perimeter, is going to equal 2.0955, blah, 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 plus the 1.9, plus the side in green, which is 1.5708, plus the 3.4. So what do we get when we put that into the calculator? We need it to the nearest integer, so we need to write it to the nearest number, whole number. So what's that going to be? Answer plus 1.9 plus, what's that number there? 1.5708. 1.5708 plus 3.4. This gives us 8.966. Blah, 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 which approximately is 9. So therefore, the perimeter to the nearest integer is 9 centimeters. And that's it. That is the question done. It's pretty easy now. I mean, I know I do these walkthroughs all the time, but this is a pretty okay question if you ask me. Okay, so question 9 says the circle C has equation x squared plus y squared plus 4x minus 30y plus 209 is equal to 0. Part A says find the coordinates of the center C and the exact value of the radius for 3 marks. So how do we go about doing that? We're dealing with a circle. To find the center and the radius, we just complete the square. So what I'm going to do is I'm going to just rewrite this so it becomes x squared plus 4x plus y squared minus 30y plus 209 is equal to 0. So I'm going to complete the square on both. Let's see what I get. So if I complete the square on that one, it's going to be x, half the 4 to get 2. Take away the square of 2, which is 4. Plus, and then complete the square on that one's going to be y. Minus half of 30 is 15. Take away the square of 15, which I always forget. Is it 225? 15 squared is 225. 225. Plus 209 is equal to 0. So what do I have here? I've got x plus 2 all squared plus y minus 15 all squared. And then I've got minus 229 plus 209 is equal to 0. That is minus 20 now. So I get x plus 2 all squared plus y minus 15. One sec. Y minus 15 all squared minus 20 is equal to 0. So moving that over, I'm going to have x plus 2 all squared plus y minus 15 all squared is equal to 20. Now remember, the general formula is x minus a all squared plus y minus b all squared is equal to r squared, right? Where your center is AB and your radius is equal to r. So just comparing with that. So the center, just set each of these equal to 0. X plus 2 equals 0 will be minus 2. Y minus 15 equals 0 will be 15. So that's the center, minus 215. So that's I. And then double I is the radius. Now remember, 20 r squared. R squared is equal to 20. So I'm going to just say then that from there, r squared is equal to 20, which means that r is equal to the square root of 20. Or I can write this as root 4 root 5, which is 2 root 5. So either one of these is fine. So r equals root 20 or r equals 2 root 5. So that is it for part A. So part A is done. Part B, it says the line L has equation y equals mx plus 1 where m is a constant. Given that L is the tangent to C at P, show that 2m squared minus 7 and minus 22 is equal to 0 for 3 marks. So let's just put that on this page here. So putting that there. Oops, Control V. All right, so we've got a circle and we've got a line which is a tangent. So let's just visualize what that looks like. So I've got a circle like that, and then I've got a tangent like that, right? Now, what does that mean algebraically? It means that if we was to solve this simultaneously, there would be one solution, sorry, right? One solution, because there's one point of intersection. One point of intersection. So how do we solve this? Well, we solve this circle, which is obviously a curve and x squared and blah, blah, blah. We got a line. You solve it simultaneously. You always get a quadratic simultaneous equation. If there's only one solution, which there is because it's a tangent, as they said, it means that the quadratic we would result in would only have one solution, which means that the discriminant must equal 0. So what we've got to do is solve this simultaneously. So we've got y equals mx plus 1. That's the line. And then we've got the circle. Which form should I use? I'm going to have to expand it back anyway. Let's use the expanded form. I think that'll probably be better. Whoops. Let's get rid of that. 5. So let's use the expanded form. So we've got to solve these simultaneously, and then we'll obviously result in a quadratic. That quadratic will only have one solution, which means that the discriminant is 0. And then we should get that result there. So we're going to solve these two simultaneously. So if I call this equation 1, and I call this equation 2. We're dealing with a quadratic simultaneous equation. One equation is quadratic, one other one's linear. You always sub the linear into the quadratic. So doing that, I'm going to say sub 1 into 2. That will give me x squared plus y, which is mx plus 1 all squared, plus 4x minus 30 lots of y, which is mx plus 1. Plus 209 is going to equal 0. So I need to get this in the form of ax squared plus bx plus c equal to 0. Figure out what a, b, and c are. So doing that, I'll do it here. X squared plus, if I expand this, that's going to be m squared x squared. So squaring that term. If I square the plus 1, I'd have a 1. mx times 1 is an mx. Double that will be 2mx. So that will just expand to become that. Plus 4x minus 30mx minus 30. Plus 209 is equal to 0. So let's tidy up. How many x squares terms do we have? We've got these two. So using that, I need to obviously factor out the x squared. So that would be, this one right here would become, if I take out an x squared, I'll put it at the front here. And that would be a 1 plus m squared, right? So that's fine. And then for the x terms, what do I have? I've got a 2mx. I've got a 4x and a minus 30mx. To be fair, that is actually just going to give me these two, this right here and that right there. That is going to be 4x minus 28mx, isn't it? Which we can then simplify. So the 2mx minus 30 is minus 28. That's fine. If I take out a, what do I need? I take out the x, don't I? Take out the x only. That will give me 4 minus 28m within it. Is that correct? Yeah, that's fine. So that would become 4 minus 28m, and then it will be x. So I've got ax squared plus bx. And then the constant term is going to be that there, which is going to be 1 minus 30 is minus 29. I can't think. Let me just do it here. I've gotten this far. Let me just do it. 1 plus 30 minus 209 is going to give me minus 178. Yeah, so therefore that's the constant term, like that. So that would be minus 178, and that will equal 0. So let's just put that in so it's clear. So this constant of 1 minus the 30 plus 209 is this term over here. Okay, let me just double check that's right. 1 minus 30. Oh, do you see what I'm saying? Do you see what I'm saying? I didn't even realize. See, that's why you always double check things. 1 minus 30, 1 minus 30 plus 209, apologies, plus 209. 1 minus 30 plus 209 is going to give me 180. I was thinking something wasn't right. Anyways, so that's done. This is our quadratic here, 180. Let me just double check again. Yeah, perfect. All right. So with that being said, we now have our quadratic. Now remember, we said that the discriminant must equal 0, right? So remember the discriminant equaling 0. Did I write that anywhere? I didn't even write it anywhere. Anyways, the discriminant must equal 0. Let me just write here. 1 point of intersection. Right? I'll write in brackets since, did they call it the line L? Yeah. So since L is a tangent. A tangent means b squared minus 4ac is equal to 0. So therefore, a is equal to 1 plus m squared. B is going to equal 4 minus 28m. And c is going to equal 180. So therefore, doing that, b squared minus 4ac is equal to 0 would give us 4 minus 28m all squared minus 4 times by 1 plus m squared plus c, sorry, not plus c, times c, 180 is going to equal 0. So tidying it up, that looks like a p. Let me change that. 28. So 28 like that. All right. So we need to show that we get this quadratic, don't we? 2m squared minus 7 and minus 22. So let's keep that as well, because we always want to have at hand what it is that you're trying to show, so that you know where you are and where you need to eventually get to. So this is where we need to get to right here. This is where we're at. So what I'm going to do, let me expand and simplify. So doing that, what's that going to be? That is going to be a 16 if I square that. If I square that, I don't know, it'll be plus something m squared. What is 28 squared? 28 squared is equal to 784. So it'll be 784 m squared. So let me just move this a bit to the side. 784 m squared. And then that one, 4 times minus 28. 4 times minus 28 is that. Double that, that's 224. So minus 224m. That is the bracket expanded. This one is going to be 720, isn't it? 4 times 180 is 720. So it's going to be minus 720. And then it's going to be 1 plus m squared, isn't it? And then I'll just expand that now. So therefore it becomes 16 minus 224m plus 784 m squared minus 720 minus 720 m squared is going to equal 0. This is where we're at, no? So then now we need to get that there. So let's tidy this up. So what do we have? We have put in the m squared first. I've got 784, take away 720. That is going to be 64 now. So 64 m squared. And then I've got minus, that's it, no? Minus 2, yeah, minus 224 m. Is that correct? Yeah, that's the only m term I see. And then I've got 16 minus 720. That minus 704 minus 720. 16 minus 720 is minus 704. Is equal to 0. Now from the show that, remember it's 2m squared. I've got 64m. Even if I'm not sure what these will simplify to you, but it just tells me I need to divide everything by 32. Right? That's the only way I'd get the 2. So dividing that by 2m squared, hopefully these will give us that. So let's do 224 over 32. 224 over 32 is equal to 7. So I have minus 7m like that. And then obviously 704 divided by 32 must give us 22. But let's just double check. 704, what is it? 7? Yeah, 704 divided by 32 is equal to 22. So therefore we get minus 22 is equal to 0 as required. So let me just put divide by 32, divide by 32, just to show the examiner we know exactly what we're doing and we're getting our A star for sure, or our A or our B, whatever you want to get. So yeah, that is that's part B done. All right, so part C says, hence find the possible pairs of coordinates of P for 4 marks. So I've got a couple of things from the other questions that we needed in order to answer this one. So first I've got to show that we just did in part B, 2m squared minus 7m minus 0. And remember, this equation was formed by applying the discriminant to this one here. Remember, they told us that the line L and the circle was a tangent, right? They said that the line L is a tangent to C, which allowed us to say that this discriminant must be equal to 0, and that's how we got m. So from the context, m, as you can see, is the m in this line here. So m is the gradient. And obviously I need this equation underneath, because remember, this equation here is essentially the solution to the points of intersection of the line L and the circle C. So what do I need to do to answer this question? Well, firstly, I need to first figure out what m is, right? The values of m, which will give us an intersection point of the line and the circle. Once I've got that, I can now substitute that value of m into this equation here, because remember, this equation, this quadratic, determines the solution of the intersection of the line and L. So once I have a value for m, I can plug it into there. And then once I find out what x is from that quadratic, I can plug it into y equals mx plus 1, and that will give us a pair of coordinates. So the question is, how many values of m do we have? Well, there's going to be up to 2 because it's quadratic. So we first need to figure out what m is. So we just need to solve this quadratic here. We can just put this into the quadratic solver, to be honest. So I'll just get the quadratic solver up. Where is it? This calculator. It's there, and it's number 3. So what is A, B, and C? A is 2, B is minus 7, and C is minus 22. So this gives me one value of m. So let me just write 2m squared minus 7m minus 22 is equal to 0. This gives us m is going to equal, what was that value? 11 over 2. So 11 over 2. Or m is equal to, if I click equals against that another one, yeah, minus 2. So these are the two values of m, right? Now, what do I need to do now? I need to plug these values of m into this quadratic here to then be able to solve it. So let's do the first one. M is equal to 11 over 2. So what would that be? Let's work out what the coefficients are first. So 11 over 2 is the first one. So what's 1 plus 11 over 2 all squared? Can put a bracket around that. That is going to be 125 over 4. So it becomes 125 over 4 x squared plus, and then what is, it's going to be negative, or will it? We'll see. 4 minus 28 times 11 over 2. So I'm just figuring out what the coefficients are. That's going to be minus 150. So it'll be negative, yeah. So it'll be minus 150 x squared plus 180 is equal to 0. So now I need to solve this quadratic, okay? So doing that, let's put this into the quadratic solver again. 5 and then 3, and I'm going to plug in 125 over 4. That's the first coefficient. The second one is minus 150, like that. And then the last one is positive 180, isn't it? So doing that, I get that value there. And why is there only one? We know there's one because obviously there's only one intersection because they told us it's a tangent. So we expected it to get 1. So anyways, when you do these type of questions, have a think about what the question was saying. They told us it was a tangent. So this quadratic equation should be 1, and I just realized I put a squared there. Apologies. So yeah, putting that in is going to be, so x is going to be 12 over 5. Now I know that x is 12 over 5. I can now figure out what y is by plugging it into there. Remember, y equals mx plus 1. We now know that the gradient m is equal to 11 over 2. And we know that x is 12 over 5. So plugging that into there, that will give us y. So y is going to equal 11 over 2 times by 12 over 5 plus 1. So what is that equal to? So let's do that there. 11 over 2 times 12 over 5 plus 1. And that gives us 71 over 5. So that is the y value. So y equals 71 over 5. So that is one answer. So possible value of P is going to be 12 over 5, 71 over 5. That is the first pair. How do we get the second pair? By plugging in m equals 2 now into the exact same quadratic. So m equals 2. Plugging that into there. That's going to be, I'll just do it to be fair. What's that going to be? It's going to be minus 2 squared is 4. Oh, that's 5x squared. 5x squared. And then that's going to be positive 56. Add 460. 60 x plus 180. Let me just double check that though, because it'll be a shame I have to refilm this. So 1 plus, I know that that's obviously 5, but you just want to be safe in an exam anyway. And then 4 minus 28 minus 2 is 60. Perfect. So now I need to solve this. So get in my solver, number 3. 5 is A, B is 60, and C is 180. And we get x as minus 6 from there. And then from here, again, we can figure out what y is, because remember, y is equal to mx plus 1. But we now know that this is when m is equal to minus 2 and x is equal to minus 6. So plugging that in there, it's going to give me y equals m, which is minus 2, times by minus 6 plus 1. I don't need a calculator for that, I don't believe. That's going to be 12 plus 1, which is 13. So therefore, y is equal to 13. So therefore, the second possible value for p is going to be x is minus 6 and y is equal to 13. So therefore, your two possible values for p, two possible pairs, are the first one, p is 12 over 5 and then 71 over 5, or minus 6 and 13. Or is it, and two possible pairs are, yeah, I think that's fine to be fair. And that is it. That is question 9 finished. All right, so question 10 says, figure 2 shows a sketch of a parallelogram ABCD. Given that the vector A to B is 3i minus j plus 4k, A to C is 7i plus 2j plus k, find an exact area of the parallelogram ABCD for 5 marks. So I'm just going to get this diagram. Again, I'm going to annotate and put it here. That way we can just annotate it. So let's plug in everything that we know. So we know the vector A to B. This is 3i minus j plus 4k. I'm going to put this in column notation as well, just because it's going to be faster to write. So 3 minus 1 and 4. The vector A to C, which is this one here. Let's draw that in. This is going to be 7, 2, and then a 1, like that. And then the vector B to C, we can actually calculate. But again, let's look at the question. The question is asking us to find the area of the parallelogram ABCD. We've got two pairs of parallel sides. The vector or the line A to C splits it down the middle, isn't it? So we've got two triangles. If I can calculate the area of one of these triangles, double it, then we're done essentially. So how do we go about finding the area of this triangle? Well, we're dealing with vectors. We've got triangles, etc. It's going to be a combination of trigonometry as well. So this question is very similar to the one in 2022. I can't remember if it was paper 1, paper 2. It was the rhombus question in 2022. Yeah, that's how I adapted it basically from there. So they love these types of questions where you've got vectors, you've got trigonometry all in one. So what do we do from here? Well, let's firstly figure out what this vector is, B to C, which is pretty easy. B to C from the diagram, we're going to go from B to A. And then once we get to A, we're going to go along A to C. So what are these two vectors? B to A is the opposite of A to B. So I'm going to just flip the signs. Minus 3, 1, and a minus 4. And then I would add on A to C, which is 7, 2, and then 1. So from there, what am I going to have? Minus 3 plus 7 is a 4. 1 plus 2 is a 3. And then minus 4 plus 1 is a negative 3. So I've got the vector B to C, don't I? This is the vector B to C. And then that will go there. And then why is this helpful? Now, because I've got all three sides, the vectors, I can calculate the magnitude of each vector, which will give us the lengths. So what I'm going to do, I'm going to actually work these out. So, for example, the magnitude of A to B is just going to be the Pythagoras of those components. So it's going to be 3 squared plus minus 1 all squared plus 4 squared. And that is going to give me 9 plus 1 is a 10 plus 16. That's going to be root 26. And then the next one, A to C, what will be the magnitude of that? That is going to be the Pythagoras of those components, which is going to be 7 squared plus 2 squared plus 1 squared. That's going to be 49 plus 4 is 53. Add another one, that's 54. So that's going to be root 54. And then the vector B to C's magnitude is going to be the Pythagoras of 4 squared plus 3 squared plus minus 3 squared, which is going to be equal to 16 plus 9 plus 9. That's 16 plus 18, isn't it? 16 plus 18, which is going to be 28 plus 6 is 34. So it's going to be root 34. So why is this helpful? I now have the lengths of each of the sides for the triangle ABC. So I'm going to just put that there. So I'm going to draw this triangle ABC again. No, not like that. That looks like a right angle. Let me try again. Hopefully that'll be better. Yeah, that's better. This is A, this is B, and then that's C. What was A to B? A to B's length was root 26. B to C's length is root 34. And then A to C's length is root 54. So I want the area of this triangle. So remember, we're dealing with triangles. Area of a triangle is a half AB sine C, isn't it? So what I need is to figure out an angle, right? If I can figure out what the angle is, for example, there, then I can just use that. Or even just a trigonometric expression for it, to be fair, because we actually don't need the angle. If I can figure out what sine C is, or sine A or sine B, then we're fine. So let's say I want to figure out what this one is here. This angle right here, or the expression for it anyway. I could first use the cosine rule, can't I, to find an expression for cos B, right? So for example, what I'm going to say then is that the area for this one, for this specifically, is going to be equal to 1/2 times by these two sides, root 26 times by root 34 times by the sine of that angle there, which is B. So I need sine B, okay? So what I can do is figure out what cos B is using the cosine rule, can't I? So I've got this angle, I've got this side, which is opposite it, it's fine. So I'm going to say, for example, cos B is going to be equal to, remember, it's just these two sides squared. So it's going to be root 26 all squared plus root 34 all squared. Take away this side, which is opposite it, root 54 all squared. Take away, sorry, not take away, divided by 2 times by those two sides, root 26 and then root 34. Like that. So let's put that in and see what we get. So we want an expression for cos B. So doing that is going to give me, what's that? Root 26 all squared is just 26, to be fair. That is a 34. And then minus, the top is just 54, isn't it, right? The squares and the square roots cancel. And then on the denominator, I'm going to have 2 roots and then 26 times by root 54, root 34, sorry. That will give me, okay, it gives me a decimal. I don't want a decimal, I need an exact value. So I need to make sure I get the exact form. So let's just do the numerator then. The numerator is going to be, what's that? Let me just get here. 26 plus 34 is 60. Take away 54. That's a 6. So that's not too bad. So I've got 6 there. And on the denominator, I can write this as 2. And then I could times these together, can't I? 26 times by 34. What is that equal to? Let's put that in there. So put it in there. That's going to be 26 times 34 is 884. So I can write this as 6 over 2 and then root 884. Okay, and then to be fair, we can simplify that, can't we? That's just going to become 3 over root 884. So this is what cos B is equal to. Now we want sine B. So we got to use our identities here. Remember sine B, remember sine squared plus cos squared is 1. So what I can say is that sine B, for example, is going to equal the square root of 1 minus cos squared B, isn't it? Right? Just from sine squared plus cos squared and right here, so it's clear. Sine squared B plus cos squared B is equal to 1. So I could figure out an exact value for sine B. So if I do that, what I'm going to do, I'm going to just say it's equal to the square root of 1 minus, and then it would be all of that squared, isn't it? 3 over root 884 all squared. So if I put that into my calculator, would that give it to me in a nice form? Square root of 1 minus, and then it would be in a bracket 3 over root 884. Like that. Close bracket, all squared. 1, let me just double check. That looks good. Doesn't give it to me. So what let me do, what if I get rid of the root? If I get rid of the root, what happens there? Okay, it gives it to me in that form, which is fine then. So what I can say there's going to be sine b is going to be equal to the square root of 875 over 884. That is what sine b is equal to. Now, from there, we can then say that the area is equal to, remember, half times root 26 times by root 34. And then now we know what sine b is. It's the square root of 875 over 884. Now, there's a couple of things I can see here. Now, we want the exact value, by the way, the exact area of this parallelogram. Now, the first thing that I notice is that that ends in a 5, right? So that could possibly have a nice root. So I'm going to do a half times by root 20. And to be fair as well, another thing I noticed as well, I'll do it after. I'm going to just say that this is root 26 times by root 34. And this is times by, using solids, I can split this, root 875 over root 884. Now, what I noticed from before is that we actually calculated what root 26 times 34 is. It's actually root 884. So therefore, I can actually say that this right here is just root 884, which we have on the bottom. So they will cancel very nicely. So I can say that it's actually just equal to, let me just cancel those. We're just going to have 1/2 times by root 875. And then let's see what that is equal to. Let's put root 875 into the calculator. Root 875, you guys can see that. Yeah, that should be fine. Root 875 is equal to 5 root 5. So therefore we have 5 root 5 there. So it's going to be 1/2 times by 5 root 35. So we're here. Now, remember, we want the exact area of this parallelogram. We said that the exact area was just twice the triangles. So all I've got to do now is figure out, or all I need to do now is double, right? Because remember, the parallelogram was 2 of these triangles, which are the exact same. So what I can now say is that therefore, the area of parallelogram is equal to 2 times the area of the triangle, because there's 2 of them. So it's going to equal 2 times by the area of the triangle, which is 1/2 times by 5 root 35. The halves cancel, sorry, the 2's cancel. So therefore the answer is just 5 root 35. And that is it. And that will give you the 5 marks. Fantastic. All right, so question 11 says the curve series equation y equals f of x, where f of x is equal to x cubed multiplied by root 4x plus 7, where x is greater than or equal to minus 7/4. Part A says show that f dash of x is equal to kx squared times 2x plus 3 all over root 4x plus 7, where k is a constant to be found for 4 marks. Okay, so I've just got everything we need for part A, just summarized here. So we've got the function f, and obviously we need to show that f dash of x is that. So if we've got the function and we need f dash, that means we just need to differentiate. So when I look at this, I can see that I've got a product of 2 functions here. So I'm going to use the product rule. So I'm going to firstly say that u is going to equal x cubed. And then I'm going to say v is going to equal 4x plus 7. But instead of writing the root, I'm going to write it to the power of 1/2, because I can see that when I differentiate this, I'm going to have to apply the chain rule. So u dash, differentiating that will just be 3x squared. V dash is going to be, the half will drop to the front when you differentiate it. So you keep that the same inside, and then you take 1 away from the power, be minus 1/2, and then you times by the inside derivative. 4x plus 7 differentiates to just 4. So I get that there, and then I can say that v dash tidied up is going to be 4 times 1/2 is 2. I can put 2 at the front. 4x plus 7 all to the minus 1/2. So this is v dash, and I'll just put u dash here again one more time. And then now the product rule states, I'll do it here, if y is equal to uv, then dy over dx, or f dash, whatever you're using, is going to be uv dash plus vu dash. So doing that, f dash of x in this case is going to be these two, uv dash. So that would be a 2 and an x cubed. I'll put that there. So I'll say f dash of x is going to be 2x cubed. And then the 4x plus 7 to the minus 1/2. And then plus vu dash, which are these two. So that way I could put a 3x squared at the front, 3x squared, and then I could put 4x plus 7 to the half, like that. So this is f dash of x, and I need it in this form here. So because I've got roots in the show that, I'm going to bring these roots back. So algebraically, this one right here, minus a half, that minus means it can go in the denominator. So I'll write this. It can go in the denominator. So I'll put 4x plus 7 here. That minus makes it go in the denominator, and that half means it's a root. So it just becomes a root on the denominator. And then this 2x cubed can just go on the top. So that is the exact same as that. And then this one is just going to be 3x squared and then root 4x plus 7, isn't it? Okay, so this is where we're at. We need to get that form over there. So we have one fraction. We have two fractions and where we're at. So remember, always use the thing that you're trying to get to as like a point of reference, right? I've got one fraction in f dash of x. I've got two terms here. Tells me I need to combine the fractions. So doing that, I can put this over 1. If I put this over 1, then the common denominator is going to be the product of these two, which is just going to be root 4x plus 7. So I'm just going to say it's going to equal, and I'll just do root 4x plus 7 for both of them. Root 4x plus 7 plus a root 4x plus 7. Now this one hasn't changed, so that's still going to be 2x cubed. This one has gone from a 1 to a root 4x plus 7. That means top and bottom had to have been times by root 4x plus 7, isn't it? Like that. So that means I've got to times the numerator by that. So we're going to do this here times by these two, aren't we? So that and that. Why am I highlighting yellow? Because these are the same thing. They've got surds on top of them, so they can just cancel. So when I times those together, I would have the 3x squared. And then the two yellows, the surds will cancel. The squares will, the square root will cancel, which will be 4x plus 7. Like that. So this is where we're at. And then now from here, we've got the same denominator, so we can combine these now, can't we? So it's going to be 2x cubed plus 3x squared and then 4x plus 7. Like that. And then we've got this all over 4x plus 7 rooted. Now we can expand. So we're going to have 2x cubed plus 3 times 4 is 12. So 12x cubed plus 3 7s are 21. So 21x squared. All divided by root 4x plus 7. Like that. And then now, doing that, what are we going to have? We can combine these terms. 2 plus 12 is 14, isn't it? So 14x cubed plus 21x squared over root 4x plus 7. And then if I'm not mistaken from the show that they wanted a factor, they want kx squared out and a 2x plus 3. Can we get that? We can take out a 7, can't we? We can take out a 7 and we can take out an x squared. And then that will give us, will that give us 2x plus 3? Let's check. Yeah, 14. Yeah, perfect. Yeah, perfect. So therefore that's it. We're done. And this is f dash of x. And then this is fine, but I think you can just say k equals 7 as well. Where k is, yeah, they say where k is a constant to be found, so just put k equals 7. And that's it. That's part A finished. All right, so part B says the point P shown in figure 3 is the minimum turning point on C. Part B says find the coordinates of P. So I've just got figure 3 and everything we need for this question. So when you see this phrase minimum turning point, maximum turning point, stationary point, blah, 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 this is just another way of saying dy dx is equal to 0, or f dash of x in this case, but just use dy dx, right? So we figured out what dy dx is, or f dash of x, I should say, in part A, which is this right here. This must equal 0. So it's this point right here, isn't it, that we're looking for? This is the point P. Now we need the coordinates, as we can see. X and Y are both negative, aren't they? So that will just give us an indicator as to what it should be. So we need to set this equal to 0, right? Set this equal to 0. We have a fraction equal to 0. The only way a fraction can equal 0 is if the numerator is 0. So immediately you can just get rid of the denominator and you can say that 7x squared times 2x plus 3 is equal to 0, which means either this is 0, so that would be x is 0, isn't it? Or this is 0. 2x plus 3 is equal to 0. And obviously, because x is negative, as you can see, it must come from this one here. So 2x is equal to negative 3. So x is equal to negative 3 halves. So that is x. We need the coordinates, so we need y. So we're just going to plug that into the original function, which is this one right here. So I'll plug in x equals negative 3 over 2 into there, and then we'll see what we get. So doing that, calculator's there. I'm going to put negative 3 over 2, all cubed, yeah, all cubed, multiplied by the root of 4 times negative 3 over 2 plus 7 gives minus 27 over 8. So therefore the point P, is it P? Yeah, the point P is minus 3 over 2 and then minus 27 over 8. Okay, so we've done that. Now part C, it says, hence find the range of the function g defined by g of x is equal to minus 4 f of x, right? Where x is greater than minus 7 over 4 for 2 marks. So this is just graph transformations. So we've got our function f, right? And they've got g, which is a transformation. It's minus 4 f of x. What does that do to your graph? Well, firstly, let's figure out what minus does, the minus about the 4. Minus f of x just reflects your graph in the x-axis. So if this is the original graph C, then minus f of x would be a reflection in the x-axis, which would look like that. Look like that, and it'll be like that essentially, right? And then this point P right here is going to be here now, and that would be because it affects the y coordinate, the x coordinate will stay the same. Let me actually label this. This point here is minus 3 over 2 and then minus 27 over 8. Okay? Hold on, let me just do it a bit better. Minus 3 over 2. I'll do it here. Minus 3 halves minus 27 over 8. That is the point P. So this point here would be minus 3 halves still. And then it would be positive 27 over 8 because it's reflected. Every y coordinate has been multiplied by minus 1, sorry. So this is minus f of x, but now they've got a 4, right? What does that 4 do? The 4 will multiply every y coordinate by 4. So essentially what that would mean for this graph here, this is currently y equals minus f of x, like that. Minus 4 f of x would just be everything quadrupled, isn't it? So let me just put it like this here, and then if I was to, what would be the best thing to do? I could just pull it up, but I want that graph. It's just going to be something like this. Like that. And then it will go like that. And then it would go basically like that. It would just be stretched 4 times, right? And every y coordinate will be times by 4. So that means at this point here, right, it's still going to be minus 3 over 2 for x. But then it would be 27 over 8, and then you would times that by 4, wouldn't you? Yeah? And then that would be 4 over 8 is a half. This would just be 27 over 2 then. This point is going to be 27 over 2. Yeah? And this graph right here is y equals g of x, right? And they've asked us for the range of this function, right? So remember, the range of a function is how high or how low your function goes. As you can see, that if I just do a horizontal line across there, this is the maximum value. The maximum value is y equals 27 over 2, right? And then anything below that is just the graph going down and down and down and down and down. So the maximum value is 27 over 2, and then the minimum just goes down to negative infinity. So we can say at the top is 27 over 2, it goes all the way down. So we just write this out. The range just goes all the way down like that to minus infinity, right? Starts 27 over 2 to minus infinity. So we can select the range then for part B, or for part C, sorry. The range is going to be g of x is going to be less than or equal to 27 over 2, just based on that graph there. 27 over 2 is the highest value, and it just goes all the way down. And you can see from the graph. So all you want to do is just visualize these, and then you're fine. So that is part C. Part D now is this. It says the point Q with coordinates a half 3 over 8 lies on C. Part D says find the coordinates of the point to which Q is mapped when C is transformed to the curve of equation y equals 40 times f of x minus 3 over 2 minus 8 for 2 marks. Again, this is just graph transformations. And if you don't know your graph transformation, you should know them very, very well. I'll put a graphic right now with all of them. Just stop the video, screenshot it. I always use this for my lessons. I always use this for my walkthroughs. I've used it for like many years. Really, really good. As long as you remember these, then you're fine. So we have this point Q which lies on C. So what I'm going to do is I'm going to say that f of x, and I always do this. I just say it's equal to that coordinate, right? And then what you want to do essentially is just work your way until you get the transformation that they want. So the first thing that I would look at is the inside, right? The x. F of x minus 3 over 2. What does that do? Well, we are working inside the bracket, so it's affecting x. Anything affect x is always the opposite. So this minus 3 over 2 will shift everything to the right by 3 over 2 units, which in turn will mean that we're going to add 3 over 2 to every x coordinate. So it's going to be like this. And then you ask us, well, what is this equal to? This is equal to 1 half plus 3 halves is 4 halves. This is 2. So currently we're at 2, 3 over 8. So what I'll do now is I'll write again, f of x minus 3 over 2 is equal to 2, 3 over 8. And then now the next thing is this 40 in front, right? Because it's closest to f. What does that 40 do? Well, that 40 means that you're going to times every y coordinate. It's on the outside. So we're going to affect y. So what that would mean is that we're going to have the 0.2, and then we have 3 over 8, and then we're going to times by 40, aren't we? Yeah. So what is that equal to? Well, 40 divided by 8 is 5. 5 threes are 15. So this is going to be 40f x minus 3 over 2. This is just going to be 215. So this is where we're at. Now remember, the last part is this minus 8. So again, you're just working your way. So now what does that minus 8 do? So 40f x minus 3 over 2. And then we're taking away 8. So again, we're taking it outside of the function. So this affects the y again. So it's going to be 2, and it's going to be 15 minus 8 now. And then from here, 15 minus 8 is 7. So it's going to be 2, 7. And that is the final answer. And that is it. So all you're doing is essentially just working with your original function, making sure you have a good understanding and memorizing all your graph transformations. You're just working your way down until you get what they want. So what I'll do actually, I think is good. I'm going to highlight everything we've done here. So we minused it there. That means we plussed it. And then we did a 40 there. We did a times by 40 there. And then what did we do after that? Then we did a minus 8, and then we did a minus 8 there, just to indicate what's going on each time. And yeah, that is, what question was this? This was question 11. That's question 11 finished. Okay, so question 12 says, show that the integral between 1 and e squared of x squared ln x is equal to a e to the 6 plus b, where a and b are rational constants to be found. This is a 5 marker. So we are integrating, and we've got two separate functions essentially. We're multiplying them. So this looks like a product rule problem if I want to differentiate it. So because I'm integrating it, it's definitely going to be by parts, because integration by parts is derived from the product rule. So whenever you see, most of the time, more often than not, if you ever see an integral problem where you're times in two separate functions, it's most likely going to be by parts. So let's get the formula for by parts. So that's going to be v du dx is equal to uv minus u dv dx, or the other way around, whatever you prefer, doesn't really matter. So the main thing is you need to pick something to be your v, the thing that you're going to differentiate, and something to be your du, something that you're going to integrate. So rule of thumb, if you ever seen ln x here, always choose that to be the thing to differentiate. So I'm going to put that as v. So I'm going to say v is equal to ln x. V is equal to ln x, can't spell. Ln x, and then du dx is going to equal the x squared. Why? Because you differentiate ln x, you get 1 over x. Just makes it a bit simpler. If you were to integrate ln x, you'd actually use by parts to do that. So you know you're definitely not going to choose that to be your du. So differentiating that dv dx, this is going to be 1 over x, and then this will integrate to become a third x cubed, doesn't it? So now we've got everything we need. We can just apply the formula. It's going to be uv, so these two, so u and v, so it's going to be a third. Let me write this. So it's going to be integral between 1 and e squared of x squared ln x, x squared ln x dx. This will equal uv, so these two, a third x cubed ln x, and then because it's a definite integral, I can put my limits on like that, and that'll be 1 and e squared minus the integral of u dv, which is going to be these two, like that. So u dv is going to be a third x cubed times by 1 over x dx, and this is going to be between 1 and e squared. And then from here, what you can do is you can simplify this a bit, can't you? So this is going to be 1/3, and then it's going to be x squared, isn't it? the x cubed and the x cancel. So that'll be like that. And then that'll be 1 squared like that. So we've got this here now. So all I've got to do is just evaluate both. So obviously this one, I'm going to work out and then evaluate. So this one will be, if I was to integrate that, then that would be, I would add 1 to the power. So it'll be a third, and then it'll be x cubed over 3, wouldn't it? Like that. And then obviously now, the 1/3 and the division of 3 will just make a ninth. So I can just rub all of that and put a ninth in the front. So it'll be a ninth like that. And then, yeah, we've got this, a third x cubed ln x between 1 and e squared as well. So we need to just evaluate both of these and then obviously get in this form a e to the 6 plus b. So let's do this one first. So we do the upper limit for this one. So it's going to be 1 over 3 e squared all to the 3. And then the ln of e squared, like that. And then minus, that would be 1/3, 1 cubed, and then the ln of 1, like that. This is that one. Now this one, we're going to do as well. So put a big bracket around this now. The upper limit is going to be 1 over 9 e squared all to the 3 minus 1 over 9 and then 1 cubed. So we just need to tidy all of this up. So firstly, I've got 1 over 3, e squared all to the 3, that's going to be e to the 6. The ln of e, right, is 1. If I bring that 2 to the front, then that will just be 2 ln e. This right here is just 2 because it's actually just 2 ln e. The ln of e is 1. So this is just times them by 2. So that's fine. I'll tidy it up a bit more in a sec. And then this one is just going to be, the ln of 1 is 0. So that is just going to be 0 there. And then take away, and then this one right here is just going to be 1/9, and that will be e to the 6. And then that will be minus the 9th, isn't it? So we're here. Let's tidy everything up now. This is going to be 2 over 3, e to the 6. That's gone. And then we have minus all of that there, like that. And then minus 1 over 9. So tidying this up now, we can expand. It's going to be 2 over 3 e to the 6 minus 1 over 9 e to the 6 and then minus 1 over 9. So we just need to work out what that is. So what we can do is we can just say that this is just going to be, if I times top and bottom by 3, it'll be 6 over 9 e to the 6 minus 1 over 9 e to the 6 minus 1 over 9. 6 ninths minus 1 ninth is going to be 5 ninths. So it's going to be 5 over 9 e to the 6 minus, let me just double check. Oh, I just realized I've got a minus there. There should be a plus, shouldn't it? That should be a plus for sure. Minus should be a plus. So that should be a plus like that. And then, yeah, so that would be actually a plus, wouldn't it? It should be a plus 1 over 9. So therefore, is that in the right form? Yeah, a e to the 6 plus b. So therefore, a is going to equal 5 over 9, and b is going to equal 1 over 9. And that's it. That will give you the 5 marks. Done. Okay, so question 13 says the first 3 terms of a geometric series are 3, 3 to the k minus 2, and 3 to the k plus 4. Part A says show that 3 to the 2k minus 7, 3 to the k minus 8 is equal to 0 for 3 marks. So whenever you're dealing with these types of questions where you've got a geometric series and it's algebraic, what you should always do is find expressions for your common ratio, right? So for example, what I'm going to do, where's my pen? There we go. So for part A, let's just say I give any random geometric series. Let's say I have, I don't know, 2, 4, 8, 16, 32, etc. We can see quite clearly that the common ratio is 2. We're just times them by 2. But obviously, if we didn't know, we could say that R is going to equal 4 divided by 2, which is equal to doing 8 divided by 4, which is equal to doing 16 divided by 8, and so on and so forth. So when you're dealing with a geometric series, just form expressions for your common ratio. Why? Because the common ratio is just defined as a term divided by the term that precedes it. So what I can do with this one is say that, for example, my common ratio R would be equal to the second term, 3 to the k minus 2, divided by the first term, which is 3. And this will have to equal the third term, which is 3 to the k plus 4 divided by the second term, which is 3 to the k minus 2. Always works. If it's an arithmetic sequence or series and you want to use something algebraic or find something algebraic, then you would find the expressions for your common difference, right? And then equate them. But with geometric, it's the common ratio. So this is where we're at now. We need to show that we get this here. So as we can see, let's cross multiply, okay? So let's cross multiply and see what we get. If I cross multiply, then that will go up there and then that will go up there. It will be 3 to the k minus 2 all squared is equal to 3 multiplied by 3 to the k plus 4. So now, expanding that, this one, if I expand this one, this is going to be 3 to the k all squared, the first term. If I expand the minus 2, that would be a plus 4. And then the two middle terms, 3 to the k times by minus 2 would be minus 2 times 3 to the k, double it would be minus 4. So it would be minus 4, and then it will be 3 to the k. So all I've done here, which I've been doing, I think, throughout the walkthrough, is just use this formula. A plus b all squared is equal to a squared plus 2ab plus b squared. So whenever you see me expand stuff like that, I'm just using this formula, and that's how I do it quickly. Next one, expanding this one. Remember, this is a power of 1, by the way. So it will be 3 to the power of, we add the powers, it will be k plus 1. And then this will be plus 3 times 4 is 12. So this is where we're at, and we want to get 3 to the 2k minus that. Okay, so what can we do from here? Well, 3 to the k, all to the 2, we can write as 3 to the 2k. And then minus 4, and then I'll keep the end of bracket, 3 to the k, and we got plus 4. And then this one, what we can do is we can split this. We can split this to become 3, and then it becomes 3 to the k. Like that. So we have 3 lots of 3 to the k, and then we've got plus 12. And then what do we need? We need that there. So this is done. We just need to move it over. So if I move it from right to left, it's going to be 3 to the 2k minus 4 times 3 to the k. And then this one I'm going to take away. So I'll put a minus 3 and then 3 to the k. And then we've got plus 4. And then we're taking away 12, and this is equal to 0. So what do we have here? We've got 3 to the 2k. We've got minus 4 lots of something. Take away 3 lots of something. That would be minus 7 lots of that thing. Like that. And then we've got 4 take away 12, which is minus 8, which is equal to 0 as required. Is that what they wanted? 3 to the 2k minus 7. Perfect. Perfect. So that's done. That's part A. Part B says, hence find the exact value of k. So part B, the exact value of k. What are we going to do? So we need to solve this. So we've got this here. How do we solve this? Well, if you look at the structure, I've got a power of 2k and I've got a power of k here. This is just a disguised quadratic. So what I'm going to do is I'm going to say let x equal 3 to the k. Then that would mean that obviously 3 to the k all squared would just be x squared. And obviously this is just 3 to the 2k. So that means that the equation just becomes x squared minus 7x minus 8 is equal to 0. So we've got a quadratic equation here. Now, how do we solve this? Just factorize. We need 2 factors of minus 8 that will add to make minus 7, which is going to be a minus 8 and a plus 1. There'll be another x there, and we have an x there. So that means then, solving each of these, that means that each of these are going to equal 0, aren't they? So therefore, x will equal 8, or x will equal negative 1. Now remember, we are solving for k, right? So we need to bring this back. So I'm going to have 3 to the k is equal to 8, and I'm going to have 3 to the k is equal to negative 1. So the question asks us for the exact value of k. It doesn't say values, there's only one solution. So one of these must not work, and it's clearly going to be this one because it's exponential. So that would mean that, remember, 3 to the k, let's just say this was the k-axis. So this is y. Y equals 3 to the k. It's going to be entirely above the k-axis. It can never equal minus 1, which is down there, right? And even if you try to log it, it won't work, right? So there's no solution here. So the only solution must come from 3 to the k is equal to 8. We want the exact value, so let's take the log of both sides. So you can either take the ln, or not either, you can take the log of any base. I'm just going to use ln. So if I take the ln of both sides, it will be ln of 3 to the k is equal to the ln of 8. And then now we can just say, well, the k can drop to the front from our log law. So we have k ln 3 is equal to ln 8. which means that, I'll do it here actually, k is going to equal ln 8 divided by ln 3. And that is your answer. Or if you wanted to just get rid of the 3, I'll do it here. 3 to the k is equal to 8. If we take the log of base 3 of both sides, which is absolutely fine, log of base 3, and then you've got this one here, log of base 3 as well, like that. And then what happens here is that this k drops to the front, it'll be log 3 of 3, which is equal to log base 3 of 8. This will be 1, so therefore k is equal to log base 3 of 8. But check on your calculator, these two are the exact same thing. So it doesn't matter which one you prefer to do, you get the exact same answer. And that's part B. All right, so part C says, determine with reason whether the geometric series is convergent for the value of k for 1 mark. So whenever you're doing these type of questions, it's all good and well, obviously knowing how to use the formula, sum to infinity, sum to n times, etc., knowing how to compute things, but you also need to have a good understanding of the topic as well. And basically think of it like a factual exam as well. There's certain facts that you just need to know. So how do we determine whether a series is convergent? Well, remember, it would mean that the modulus of r has to be less than 1, right? So let me write this here actually. So series is convergent if, series is convergent. I'm going to run out of room, aren't I? Yeah, I am. Series is convergent if the modulus of r is less than 1, yeah? Which in other words, that just means that r is between 1 and -1, right? Because you want the terms to get smaller and smaller, so r would have to be fractional. So all we need to do to answer the question is determine what the common ratio is. And what I've actually got here is what we did in part A. Remember, we set two expressions for the common ratio equal to each other to solve for k. Now we know what k is, and k, by the way, if I'm not mistaken, it was log base 3 of 8. There were two forms I used, but I'm going to use this one because it's going to be easy to simplify. It's going to be nice to simplify. So all we need to do is figure out what the common ratio is and just see whether or not it satisfies r being between -1 and 1. Simple as that. So I'll use this expression. So I could use either one of these, right? I'm going to use the one on the left. So I'm going to say that it's going to become r is going to be 3 to the k, which is log base 3 of 8 minus 2, and I will divide that all by 3. So from here, what happens? Well, 3 and log base 3, these will cancel out. You're going to have 8 take away 2. Divided by 3, that's 6 over 3, which is equal to 2. So therefore, r is equal to 2. And what does that mean? Well, the modulus of r, right, has to be less than 1. So since r equals 2 is outside the range of convergence, the series does not converge. Series does not converge, right, for the value of k, and that k was equal to log base 3 of 8. And that's literally it. That's all you've got to do. And that is our question 13 finished. All right, so question 14 says, given that cos 2 theta minus sine 3 theta is never equal to 0, prove that cos squared theta over cos 2 theta minus sine 3 theta is identical to 1 plus sine theta over 1 minus 2 sine theta minus 4 sine squared theta for 4 marks. So I've just got it summarized here. We're dealing with a standard trigonometric question, show that comes up all the time. So we've got this left-hand side here, and then the right-hand side, what I can see immediately is that it's all in terms of sine. That tells me that when I'm using my identities, etc., I want to get them all in terms of sine. So firstly, let's start with the numerator. We've got cos squared theta, which we should know is 1 minus sine squared, so that's fine. Then if I look further, we have 1 plus sine. How is that even possible? How have they got that? Well, remember this here, 1 minus sine squared. If I put a whole squared here, which I can do, 1 squared is 1. This is just the difference of 2 squared. So this actually just factorizes to become 1 plus sine theta and then 1 minus sine theta. So that is the numerator factored, and that's great because we've got that 1 plus sine theta there. Now, the denominator, cos 2 theta. So that one, again, this is just your double angle formula for cosine. It's not in the formula book. You've got 3. You've got cos squared minus sine squared. You've got 2 cos squared minus 1. And you've got 1 minus 2 sine squared. Which one do you use? Just depends on what you're trying to show. So everything is in terms of sine. So it makes sense to use the 1 minus 2 sine squared theta. Now, the sine 3 theta is where it gets a little bit trickier. So you may have seen this with your past paper revision. if you've got a 3 theta here, whether it's sine 3 theta or cos 3 theta, what you should always do is break down that 3 theta. Sorry, I wrote cos. You should break down that 3 theta so that you can get a 2 theta and use your double angle and compound angle formula. So what I'm going to do is I'm going to say that this is actually just sine of 2 theta plus theta, right? And then from here, I can use the compound angle formula to expand this. I'll just do it here. Sine of A plus B. This is equal to sine A cos B plus sine cos A sine B. So we can see that A is going to be 2 theta and B is going to be theta. So that means that this just becomes sine 2 theta cos theta plus cos 2 theta sine theta. Okay. So this is where I'm at. And what are we trying to do here? We are trying to get everything in terms of sine, aren't we? So what we're going to do is we have to deal with this a bit better. So the numerator is done. Cos squared theta is 1 plus sine 1 minus sine. The cos 2 theta we've written as 1 minus 2 sine squared. Now this sine 3 theta we need to just keep on doing. So immediately, again, double angle formula. Sine 2 theta is 2 sine theta cos theta. So I'm going to write 2 sine theta cos theta. And then I'm going to write another cos theta. Plus cos 2 theta, which again, we're going to use the sine version. 1 minus 2 sine squared theta. And then a sine theta on the outside. And now, remember what we're trying to do. We're trying to get everything in terms of sine. So let's simplify a bit. I'm going to have 2 sine theta. And then I'm going to have cos and cos times, which is going to be cos squared. And then we're going to have, if I expand that one, that's going to be a plus sine theta. And then minus 2 sine cubed theta. And then from here, cos squared theta, again, we can replace with 1 minus sine squared. So we have 2 sine theta. And then 1 minus sine squared theta. And then plus sine theta. And then minus 2 sine cubed theta. And then now, this is great. This is all in terms of sine. Let's expand this. It's going to be 2 sine theta minus 2 sine cubed theta plus a sine theta minus 2 sine cubed theta. So this is where we're at. Now we can tidy this up a bit more. 2 sine theta plus a sine, that's going to be 3 sine theta. And then we've got minus 2, that's minus 4. So we get minus 4 sine cubed theta. And this is equal to sine 3 theta. And this is actually a standard result. So you can memorize it if you want, but this is how you would prove it because they can actually ask you just to do it like this. So now that we've got that, we can now put everything into the left-hand side. So remember, this is the left-hand side. I write LHS for left-hand side. Cos squared theta, we know is 1 plus sine, 1 minus sine. So 1 plus sine, 1 minus sine. All divided by cos 2 theta, which is 1 minus 2 sine squared. Take away, and then we are taking away sine 3 theta, which we know is this. Now, because there's more than one term we're taking away, we need to put a bracket. So it's going to be 3 sine theta minus 4 sine cubed. Okay, so now we are here. Let's tidy this up a bit more because we can expand the denominators, can't we? So let's do that and see what we get. So it's going to be 1 minus 2 sine squared theta minus 3 sine theta. And then I've got 2 negatives though. Now minus will be plus. So it'll be plus 4 sine cubed theta. This is the denominator. The numerator is still 1 plus sine, 1 minus sine. Okay, so this is where we're at. What I'm going to do, I'm going to copy this and put this on the next page. Let me copy this. This is where we're at so far. This is the left-hand side. And we've got the show that there. So what I'm going to do, we get that there, and then move that there. Let me move this over here. So remember you're dealing with show that. So look at where you're at and where you need to get to just help you decide what to do next, essentially. So the right-hand side, we just have a 1 plus sine theta on the numerator. We've got a 1 plus sine and a 1 minus sine. And on the denominator, they've got a quadratic, we've got a cubic. So something has been divided, essentially, right? Something has been reduced. So when we look at this, because I've got a 1 plus sine theta here, and I've got just a 1 plus sine theta here, what this tells me with 100% certainty is that this 1 minus sine theta must cancel with a factor on the denominator. So essentially, this cubic factor will factorize. There will be 1 minus sign coming out. So I just need to show that, right? So what I'm going to do, just to make things easier, I'm going to say let sine theta equal s. And that means that I have 1 minus 2s squared plus, sorry, not plus, minus 3s plus 4s cubed, right? This is a cubic. Let me write this in order of powers. So 4s cubed minus 2s squared minus 3s plus 1. Okay, so from here, we know that this 1 minus sign, or 1 minus s, I should say now. Let me write it as 1 minus s. So the top would be 1 plus s and 1 minus s. I know that 1 minus s factors into this here. How can I show it though? Well, I can use the factor theorem, right? If I set 1 minus s equal to 0, then that would just mean that 1 is equal to s, or s equals 1. So if I plug s equals 1 into this, and I get 0 out, that will definitely tell me that 1 minus s is a factor. So let's do that and see what I get. So s equals 1 into there. What do we get? We're going to have 4, then 1 cubed, minus 2 lots of 1 squared, minus 3 lots of 1 plus 1. What is that? That's 4 minus 2 minus 3 plus 1. That is 4 plus 1 is 5, minus 2 minus 3 is minus 5. This 5 minus 5, which is equal to 0. So that tells me, therefore, 1 minus s is a factor. So now that I know for sure that it is a factor, I need to figure out what that quadratic factor is, which is obviously going to be this one, just based on the show that, but you need to show it. So you can either use long division or equate coefficients. I'm going to equate coefficients. So essentially what I'm saying here is that this 4s cubed minus 2s squared minus 3s plus 1 can be written as 1 minus s multiplied by a quadratic factor, which you can call as squared plus bs plus c, for capital C. I need to figure out what A, B, and C are and show that it matches this here. Let me just make sure you guys can see that. I hope my face is not in the way. So, and to be honest, I think this is the only way you can do it. I don't think there's like a clean way to factorize it without doing this. So let me know in the comments how you guys did it. But yeah, so what I'm going to do, I'm going to expand this. If I expand this one with each of these, then that is just going to be an as squared plus a bs plus a c. And then when I expand the minus s with all of that, it's going to be minus a s cubed. And then it's going to be a minus b s squared, and it's going to be a minus cs, isn't it? And then now let's tidy this up a bit. So what do I have? I've got minus as cubed at the front, and then what else do I have? I've got the s squared terms I need to do, which is going to be plus as squared minus bs squared. And then for the s term, what do I have? I've got a plus bs, and then I've got a minus cs. And then for the constant term, I've just got a plus c. And then now what I want to do is get it in the form of coefficient x cubed, coefficient squared, and so on and so forth. So this is just going to be 5 minus as cubed. If I factor out the s squared, I'm going to have an a minus b and an s squared from those two terms. This one, I'm going to factor out b minus c. And that will be an s, and then that will be a plus c. So now, if I bring this back, we can just easily equate coefficients now, can't we? So I'm going to have minus 2s squared minus 3s plus 1. So now, what does that mean in terms of equating coefficients? It means that the coefficient of s cubed on this side has to be the exact same as that side. So that means I can say that 4 is equal to minus a. So that just makes mean that a is equal to minus 4. So that's done. And then now, minus 2, let me do a different color actually. Minus 2, this minus 2, the coefficient of s squared on this side must be the same as that side. So that means I can say that minus 2 is equal to a minus b. And then obviously we know what a is. A is minus 4. So minus 2 is equal to minus 4 minus b. So that means that, for example, if I move that there, then that is going to be a 4 minus 2, which would be a 2. 2 equals minus b. So therefore, b is equal to minus 2. And then the constant term, c, is pretty easy actually. C is just going to be 1 from there, isn't it? We don't even need to equate the s term. That there and that there, we can just say that c is equal to 1. So therefore, we've got a, b, and c. Let's try to say a is equal to minus 4 B is equal to -2, and C is equal to 1. Does that check out with our quadratic? Let's put this in there. That means that this one right here is going to be 1 minus S, and then it's going to be minus 4S squared minus 2S plus 1. And then if I just compare that to what I've got, that's exactly what they've got there, isn't it? Just in the other way. So therefore, I can actually just write this as 1 minus S, and then put it the other way, 1 goes first, minus 2S minus 4S squared. So now we've factorized it fully. So then now we can bring this back. How much room do I have? So I can bring this back. So therefore, I can say then that this right here can actually just factorize to become this. So copy. Let's bring the sine theta back. And then we can say here that we have this there. And then what we can say is that this is now equal to 1 plus sine on the top. Hold on, let me make this straight. I wonder how long this is going to take. So, or how long it's taken. So 1 plus sine, 1 minus sine. And then this denominator, we can now say it's factored to become 1 minus S, which is 1 minus sine theta, multiplied by 1 minus 2S minus 4S squared. 1 minus 2 sine theta minus, and is it minus? Yeah, minus 4 sine squared theta. Like that. And then from here, we can see quite clearly, cancel, cancel. So therefore, we get 1 plus sine theta on the numerator divided by 1 minus 2 sine theta. Whoops, put this there. Minus 4 sine squared theta. And I don't know why I put the extra bracket here. Don't need it. And I think that's it. Let's just check. 1 plus sine theta, 1 minus 2 sine theta minus 4 sine theta squared as required. And that is it. Literally that. Fantastic. That took a long time. I'm going to check how long it's taken. But yeah, let me know in the comments how you guys did it. I don't think there's any other way to do it cleanly without doing the long division or equating coefficients. So yeah, that's part A done. All right, so part B, it says hence solve for 0 to 360. Cos squared theta over cos 2 theta minus sine 3 theta is equal to 2 cosec theta. Give your answers to one decimal place for 5 marks. So I've just got what we've done in part A summarized. Remember, there's a standard trigonometric question. Part A is show that this identity is equal to that. And then obviously part B is hence, based on what you've shown, solve this equation. So the first thing that you want to do is obviously identify that this expression right here is exactly what you showed to be something else in part A. So you're going to replace it. Right, so first thing you're going to do is you're going to say that, well, it's going to be 1 plus sine theta, 1 plus sine theta over 1 minus 2 sine theta minus 4 sine squared theta is equal to 2 cosec theta. But remember, cosec is 1 over sine. So 2 cosec is 2 times 1 over sine, which is just 2 over sine theta. So you're also going to replace the right hand side as well. So remember, your identities are super, super important, okay? And just as another thing to say as well, as you can see, we used what we did in part A, but even if you weren't able to access the marks in part A, you weren't able to prove the identity, it doesn't mean you can't do the part B's of this question as well. So that's something I forgot to mention, but super important. Anyways, we are here now. We've got an equation all in terms of sine. Let's just cross multiply. So times that up, that would be sine theta times by 1 plus sine theta is equal to 2, and then 1 minus 2 sine theta minus 4 sine squared theta, like that. And then now expanding that is going to be sine theta plus sine squared theta. This will equal 2 minus 4 sine theta minus 8 sine squared theta. And then from here, let's move everything from right to left. It's a quadratic, isn't it? So it's a quadratic and sine theta. So that would be sine theta plus sine squared theta. And then let's move everything from right to left. It's going to be minus 2 plus 4 sine theta plus 8 sine squared theta is equal to 0. So then now what do we have? We have sine squared. We've got sine plus 8. We got 1 plus 8, which is 9. So I have 9 sine squared theta I've got a sine theta plus a 4 sine theta. That would be a 5 sine theta. And then I've got a minus 2. And that is going to equal 0. So we've got this quadratic here. So how do we solve it? I believe you can use the calculator from here just because of the fact that you've done the algebra and got this quadratic. So you could put it to the calculator. I'll just use the quadratic formula just for completeness. So what I'm going to do is I'm going to let x equal sine theta just because it's going to be easier and faster for me to write. That means I'm going to have 9x squared plus 5x minus 2 is equal to 0. So that means that the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, will just become, it will be minus 5 plus or minus the square root of 5 squared minus 4 times 9 times by minus 2 all over 2a, which is going to be 2 times 9. So I'll put this into the calculator and see what we get for that, just so it can be simplified. So I'll just put the plus in first, and then square root 5 squared minus 4 times by 9 times by minus 2 over 18. Or just I'll put 2 times 9 in just because it's for completeness anyway. So that would be that there. So therefore we can say that x, which is sine theta, we could just say that x is equal to minus 5 plus or minus root 97 over 18. So remember, because x is sine theta, it now means that we need to solve sine theta for those two. So I'm going to just put this on the other page. So I'm going to say that sine theta is going to equal, what was it? Minus 5. And then the first one will be plus root 97 over 18. And then the other solution is going to be sine theta is equal to minus 5 minus root 97 over 18. So we just got to solve both of these equations between 0 and 360. And then we're done. Yeah, we were done. So let's do that and see what we get for that. So firstly, let's do this one on the left. If I take the sine inverse of that, that will give me theta. So let's see what I get for that. So I'm going to do shift sine inverse of that. My calculator is in degrees, which is fine. That will give me 15.627. So 15.627 degrees. And then remember, when you're dealing with sine, you can solve it however you like. You can use the cast diagram, you can sketch the graph and look at the symmetry. I think it's personally easier just to memorize it. So with sine theta, whenever you solve it, I'll just show you. So sine theta equals k. Your first answer is going to be theta when you do the sine inverse. The second answer is going to be 180 minus whatever angle you get when you do the sine inverse like that. And then obviously to get the ones after that or before it, for example, you're just going to add 360 and so on and so forth. So the next one is going to be literally 180 minus that 15.627. That will give me the next one. So I'll do that and I'll see what I get. So I'll do 180 minus answer. That gives me 164.372. 164.372. And then from here, as you can see quite clearly, if I was to find the next solutions, it will take me outside of the range because we would need to add 360 to both of these to get the third and fourth solution from the first one. So we can stop here. This is definitely the two answers here. So remember, what accuracy did they want to do? They wanted to one decimal place. So what I'm going to say is that theta from there is going to equal 15.6 degrees and 164.4 degrees. So we have solved this equation. We now need to solve this one here. So solving this one, we're going to do the sine inverse of that number there. So what I'm going to do is let me put this into the calculator. So minus 5 minus root 97 over 18. That gives me that there. And then I'm going to do the sine inverse of that. And this gives me that number there. So minus 55.58. Let me just do one more decimal place. 2. So remember, as I said before, to get the next solution, it's going to be 180 minus whatever angle you got. So it's going to be 180 minus, and then minus 55, isn't it? 0.582. So what do we get? We put it in. 180 minus answer is going to give me 235, right? So 235.582, obviously, isn't it? Yes, of course. 582, blah, blah, blah. So these are our two solutions. Remember, we want it in the range of 0 to 360. To get the next one after this one, we would add 360, wouldn't we? But that is great because that's a negative number. So it's actually 360 take away that. So that will still give me the values inside the range. So I'm going to do, let me put add 360 there. You know what I'll do actually? I think it's be easier. Let me bring this down. put this down here. And that. I think that's easier to do. And I just put a line just to indicate that I'm solving this equation here. And I think I grabbed, that should be 180 minus like that. And then rub that out. Okay, so then that tells me then to get this one, what I'm going to do simply is add 360 to get this solution right here. So it's going to be that number there. Can I get it? If I click equals, no, I won't click it. Anyways, it's fine. I'll just do this. I'll do minus 55.582. And then I would add 360, wouldn't I? And that will give me 304.418. So therefore, the two solutions here to one decimal place in the range of 0 to 360 would be 235.6. And then it would be 304.4. I believe that's it. That's done. Let me just double check my answers. Because it'll be a catastrophe if I have to do this again. Yeah, I think that's all good. Can't even check. Yeah, that's fine. So therefore, your final answer, to get all 5 marks, you need to get all 4. So it will be, I'll do it in order of size. 15.6 degrees, 164.4, 235.6 degrees, and 304.4 degrees. And that is the final answer. That will give you the 5 marks. And that's it. That's question 14 finished. All right, so question 15 part A says, by writing sec theta as 1 over cos theta, show that when x is 3 sec theta, the xt theta is equal to 3 sec theta tan theta for 2 marks. So I've just got this summarized here. So it's only 2 marks, and I think this is a standard derivative in the formula book. So how do I go about doing this? Well, firstly, what we can say is, because they've told us obviously sec is 1 over cos, we know that anyway, but we can say that x then is going to equal 3 times by sec, which is 1 over cos. Which means that I can just write this as 3 over cos theta. And then what I'm going to do, because I want to differentiate this, just write this as a power. So the 3 will obviously stay the same. And then the cos theta, if I bring that up, I need to put it all to the -1, don't I? So what I can say from here is that x is going to equal 3 cos theta to the -1. Now, why have I written it like this? Because it's a composite function. To differentiate this, we need to use the chain rule, don't we? So if I differentiate this, I'll have dx d theta, right? And this will equal, the 3 will stay the same. Obviously, it's a constant. That -1 will come to the front. It'll become -1 times by cos theta. That will stay the same. And then we just take 1 away from the power, like normal differentiation. And then what we do now, to apply the chain rule, we have to multiply by the inside derivative. What do we get when we differentiate cos theta? It goes to minus sign. Put minus sign there. Then now, if I tidy this up, what am I going to have? I'm going to have dx d theta is equal to, I've got minus and a minus, that would be a positive. I've got 3 sign. I have 3 sign at the front. And then I've got cos theta to the -2. So we need to show that it says 3 sec theta tan theta. So we've got the 3, which is fine. We need to show that that's sec and that's tan. So what I can do is, remember, identities, tan is sine over cosine, sec is 1 over cosine. So as long as I can show those here, then we're pretty much done. So what I'm going to do now is I'm going to say that I've got 3 sine theta, like that. And then I'm going to rewrite the cos theta as 1 over, and then that would be cos squared theta, isn't it? If I bring it down. And then from there, I can distribute this cos squared. So it becomes 3 sine theta times by, and because it's 1 over, surely I can write like this, 1 over cos theta times by another 1 over cos theta. Right? That's the exact same as 1 over cos squared, and we want 3 sec tan. So all I have to do is this. Very, very clever. Just change the order. I have 3, and I'm going to times by, I'll put this one at the front. So 1 over cos theta. And then times by, and then these two, I can bring together, no? Sine times 1 over cosine. That becomes sine over cosine, doesn't it? And then from here, what is this equal to? Well, we have 3. 1 over cos is sec. Sine over cos is tan. So therefore, we got dx d theta is equal to 3 sec tan theta as required. And that's all you got to do for the 2 marks. All right, so part B says figure 4 shows a sketch of part of the curve C with the equation y equals root x squared minus 9 over x, where x is greater than or equal to 3. The finite region R, shown shaded in figure 3, is bounded by the curve C, the x-axis, and the line with the equation x equals 6. Part B says use the substitution x equals 3 sec theta to find the exact value of the area of R. Solutions based entirely on graphical or numerical methods are not acceptable. This is 7 marks, so we are dealing with an area bounded by the curve and the x-axis with limits 3 and 6. This is definite integration. Now, obviously, they've said use the substitution. So it's more specifically integration by substitution. Now, first things foremost, before we get started, we're dealing with calculus, which is integration. And we're dealing with trig, right? So what you should do is make sure your calculator is put into radians, right? Whenever you're dealing with trig, calculus should always be in radians. So that's the first thing that you should do. I think mine is already in radians, so that's fine. Now, we're dealing with substitution, integration by substitution. Remember, it's like a game. You start with an integral in terms of x, which is complicated to solve. So then you use a change of variable, typically u, in this case theta, to transform into an integral that you're more familiar with and capable of solving. So what is the area R defined by? Well, let's actually write that out. So where's my cursor? There we go. So R, which is what we're looking for, is going to be the integral of this curve, which is root x squared minus 9 over x dx between the limits of 3 and 6, isn't it? Yeah, 3 and 6. So this is what we need to calculate. Now we're going to use substitution, right? Now remember, we know that x is 3 sec theta. They told us that. So x is equal to 3 sec theta. And then in part A, remember, we figured out that the x d theta was just equal to 3 sec theta tan theta. So all we need to do is just use these substitutions to figure out, or to at least get the integral in terms of theta. So from here, what I can do actually is dx, you can times that up, can't you? So you can say dx is equal to 3 sec theta tan theta d theta for sure. So let's plug in everything. We've got to do the limits as well, by the way. So what I'm going to do, I'm going to just plug in everything there. So it's between 6 and 3 still. And it's going to be the square root of x, which is 3 sec theta. So x squared, sorry. 3 sec theta all squared minus 9 all over x, isn't it? Which is going to be just 3 sec theta. And then dx is this thing here, which is going to be times it by 3 sec theta tan theta d theta. Okay? And then now what we can do, which I think is going to be good, let's try and simplify as much as we can and then deal with the limits. So I'll put this on the next page and then we'll just use that there. So put this there. And then now what we can say then is that, or that numerator, or to be fair, before the numerator, we can see that we've got 3 secs, don't we? We've got 3 sec theta there. We've got 3 sec theta there. Those can cancel straight away. So if I cancel those, be like that. And then I've got this here in the numerator. So let's do that. So I've got the square root of 3 sec theta all squared is just going to be 9 sec squared theta. And then I've taken away 9. And then when I look at this immediately, what I notice is that I've got a common factor of 9. I can factor that out. So it becomes 9. And then I've got sec squared theta, take away 1. And then from our third laws, remember third law, root AB is equal to root A, root B. I can split this. So it becomes root 9, and that becomes root of sec squared theta minus 1. That there is 3. So it's just literally 3 times by sec squared theta minus 1. This is just the numerator I've been working with. Now, even further, sec squared minus 1, that should ring bells in your head. You should recognize that identity. That's just a Pythagorean identity, which is 1 plus tan squared theta is equal to sec squared, right? And then from there, if I rearrange this, take 1 away from both sides, tan squared theta is actually just sec squared theta minus 1. So therefore, this right here is actually 3 multiplied by tan squared, right? We're square rooting tan squared, that will just cancel the square and the square root, so it'll just be 3 tan theta. So the numerator actually is just 3 tan theta. So what I've got then is I've got the integral between 3 and 6 of the numerator, which is 3 tan theta. We cancel the 3 secs, and then we're times it by tan theta d theta. This is where we're at. So then therefore we can say that the integral is just between 3 and 6 of 3 tan squared theta d theta. Now, we've simplified it quite a bit, which is good. Now let's look at the limits, right? We've got x between 3 and 6. So typically when you do this type of questions, they give you like a range of theta. They haven't given it to us explicitly, but we can derive it. Now they've told us that x is greater than or equal to 3, haven't they? And we know that x is 3 sec theta. So since x is greater than or equal to 3, I'll do it here. This is from the question, x greater than or equal to 3. And we know that x is 3 sec theta. We can say that 3 sec theta must be greater than or equal to 3. Divide both sides by 3. We've got sec theta must be greater than or equal to 1. So what does that mean? If you were to sketch sec theta, which you should know what it looks like, when is it greater than 1? Well, it's greater than 1. So this is going to be, whoops, that shouldn't be like that. So it should be like this. Come on. Yeah. So it should be like this. So we got this there. The graph of sec theta at 0 starts at 1 and goes up like that. And then this is an asymptote of pi over 2. Like that. This is between 0. So this is the graph of sec theta. So let's imagine this is theta. This is y. This is the graph of y equals sec theta. It's greater than 1 between 0 and pi over 2. So when I'm solving for theta, when I'm doing my change of limits, remember it needs to be 1 to 1, essentially. Sec theta is 1 to 1 in this range. So we're going to use the limits, the range, sorry, of theta between 0 and pi over 2. Technically, I should actually remove that equal sign there because pi over 2 is undefined because you'll be divided by 0 because 1 over cos. So when I'm solving for sec, when I'm solving for theta, when I'm doing my change of limits, I can just use that. So what is sec equal to? Or no, what is x equal to? X is equal to 3 sec theta. And then we got to change these limits, right? So if x equals 6 there, if x equals 6, then that would mean that 6 is equal to 3 sec theta. And then if x is equal to 3, that would mean that 3 is equal to 3 sec theta. So I've got to figure out what theta is between 0 and pi over 2 from these two equations. Let's do the first one. Here, that would be, if I divide by 3, I'm going to have 2 is equal to sec theta. And then if I divide this by a thing, I'm going to have, by 3, I'm going to have 1 is equal to sec theta. So I put this equation 1, I put this equation 2. Equation 1, if sec theta is equal to 2, remember we don't have sec on our calculator, so we got to change this to cos. Just flip it, do the reciprocal. That means that cos theta is going to equal 1/2. And then number 2, if sec theta is equal to 1, then that means that cos theta will also equal 1 as well. So now let's just figure out what theta is between 0 and pi over 2 for these. So just plug that in. So cos inverse of 1/2, cos inverse of 1/2 is going to equal pi over 3. So that means that theta is going to equal pi over 3. And then this one here is going to be 0, I believe. So 0. Oh no. What have I done? Oh, sorry. Cos inverse of 1, not 0. Cos inverse of 1 is 0. Yeah. Cos inverse of 1 is 0. So these are our limits. Upper limit is pi over 3. Lower limit is 0. So therefore, oh, I've run out of room. No, I need another page. All right. I'll have to change that when I'm doing the paper. So that means that the integral, I'll do it here. That means that the integral is going to be, remember it's 3 and 6. The new limits are going to be 0 and pi over 3. And then we're solving this, we're solving 3 tan squared theta, d theta. So from here, this is what we're solving. This is where we're at. So now what do we do? Well, we're dealing with tan squared. Now, are there any identities you can use to change that? For sure, we've actually just seen it already. Remember, 1 plus tan squared theta is equal to sec squared theta, right? So tan squared theta is equal to sec squared theta minus 1. Now, why would I want to replace it with that? Because if I integrate tan squared like that, then I'm integrating that. Sec squared theta is the standard derivative. It's the derivative of tan. So I know what that is. And then 1 integrates to theta. So these two are easy, right? As long as you just remember that tan differentiates to sec squared. So that means that sec squared integrates to tan. You can just use that. So what I'm going to do is I'm going to say this just becomes 3, and then it's going to be sec squared theta minus 1 d theta, right? Between 0 and pi over 3. So from here, what I can do is let's pull up that 3. I don't need that. I can just times that on at the end. So it's going to be pi over 3 and then 0 and then of sec squared theta minus 1. And then as I said before, when you differentiate tan, if I do differentiating tan like that, this is just sec squared theta. You can use this, you can prove this using the quotient rule. So it means if I integrate it, I'll get back to the start. Yeah. So then that means that this is just equal to 3, and then put the limits of integration in. Sec squared is tan, and then 1 will integrate to be theta, and between 0 and pi over 3. So all I've got to do now is plug this in. I put a 3 and I put a big bracket in. Evaluating the limits now is going to be tan of pi over 3 for the upper limit minus pi over 3. Take away the lower limit, which is going to be tan of 0 minus 0. Like that. Now, tan of 0 is 0, so it's 0 is 0. So that just cancels out. That's just a cross there. And so therefore it's just equal to 3 times tan of pi over 3 minus pi over 3. Expanding that, that's just going to be 3 tan pi over 3 minus 3 times pi over 3. The 3's will cancel, be pi. So therefore, the answer, what is tan of pi over 3? Let's put that in. Tan of pi over 3 is equal to root 3. So therefore, we have 3 root 3 minus pi. And that is the final answer. I ran out of room. I need another page. But yeah, that will give you the 7 marks for part B. And that's it. And that is the entire paper finished. Hey guys, so yeah, that's the paper done. 15 questions. Hoping that you guys have found it helpful with your revision. Any questions that you may have found it a bit tricky, I'm hoping that this walkthrough, this video has helped you understand it a bit better and you're feeling more confident with your exam. So moving forward, this is obviously predicted paper 1. Once paper 1 is out on June the 3rd, I'll have a look at it and then I'll do paper 2. So hopefully that should be out within a couple of days after paper 1 is out. And then yeah, we'll just do another predicted paper. And then obviously after that, paper 3, I'll do a predicted paper 3. So there'll be 2 more predicted papers from me. Anything else I need to say? Yeah, in terms of this exam season, this exam period, if anyone's ever looking for some extra support, I do offer weekly classes for A-level students. So Wednesdays I do pure mathematics and Fridays I do applied. So I'll put more information in the description about that as well. So if any of you are interested in joining, feel free to come along. But yeah, I think that's pretty much it in terms of what I need to say in terms of the papers, etc. And yeah, also as well, I did do some Easter courses over the Easter period as well, which you guys can access on my website and purchase if you'd like. So we did about, I think it was about 5 or 6 questions over 2 sessions. So we did 10 questions altogether. So yeah, more information will be in the description about that as well. And yeah, just wishing you guys the best of luck. Let me know how you guys got on with this paper, what you got, what marks you got, what questions you found a bit tricky. Let me know especially how you got on with question 14, the trigonometric identity one, because the way I did it in the video is the only way I could think to do it and was probably the best way. So interested to figure out or interested to see how you guys got on with this paper. But again, wish you guys the best of luck with your exam. You guys are going to do amazingly well. And again, if you found this video helpful, any of my videos helpful, it's always appreciated if you like, comment, subscribe, share with your friends, share with anyone that you think may find this video and these resources helpful. Helps the channel grow. So yeah, that's pretty much it. Again, wish you the best of luck and I'll see you for predicted paper 2. Take care. Bye-bye.